मैं बोल रहा हूँ माइक पे, ठीक है। इसकी मास्टर बंद कर। रुक जा, हाँ अब सुन। हेलो, आ रही है मेरी आवाज? नहीं, उसमें नहीं आ रही यूट्यूब में। हेलो, हेलो, नहीं आ रहा। हेलो, चेक टेस्ट, माइक्रो टेस्ट, हेलो चेक, हेलो 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 चेक, हेलो 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 चेक, हेलो। अब आ गया। हेलो हेलो, थोड़ा लेट आएगा, वो कुछ कुछ सेकंड लेट आएगा। आ रही है ना? क्या कह रहे हैं? हाँ, तेरा ऑडियो नहीं आएगा, तेरा तो सिर्फ माइक पर सुन रहा हूँ मैं। हेलो हेलो, हेलो, आवाज आ रही है राम? हेलो, हैं? तेरा नहीं जाएगा, मेरा ऑडियो आ रहा, सुनाई दे रहा तेरे को? आ रहा ना? आप जा रहे हो सर? एक मिनट रुक जा सर, आ रहे हैं। हेलो, ठीक है ठीक है।
Good morning, everyone. I am Varnika Prakash from the Indo-Swiss Building Energy Efficiency Project. And on behalf of the Bureau of Energy Efficiency and Indo-Swiss BEEP, I welcome you all to this national workshop on energy efficiency in the Indian residential sector. Thank you so much for gracing us with your presence. We also have quite a few participants who've joined. Sorry, so we also, this is a hybrid workshop, so we have quite a few participants who are joining us through Zoom and YouTube Live. So there was some technical glitch. Apologies for that. There are a few changes in today's program, and you would have the advised agendas with you. It's because there was some emergency at the Ministry of Power, and quite a few dignitaries from BE and MOP have been taken because of that. So I'd request Ms. Akansha Krishan, Sector Expert, Bureau of Energy Efficiency, to give us the welcome remarks.
Thanks, Varnika. Good morning, ladies and gentlemen. We extend a very warm welcome to all of you. As a part of Azadi Ka Amrit Mahotsav, the National Workshop on Energy Efficiency in Residential Building Sector is organized by the Bureau of Energy Efficiency under the guidance of Ministry of Power, partnering with the Indo-Swiss BEEP project. We are celebrating the iconic week ahead of the National Energy Conservation Day planned for 14th of December. So the Honorable Prime Minister of India at the COP26 in Glasgow announced a pledge that India will achieve net zero emissions by 2070. This aligns with the climate emergency that we are facing, and it also gives us an opportunity to propagate suitable and sustainable ways of living based on traditions and values of conservation and moderation. Energy efficient building design is essential not only to keep buildings thermally comfortable, but also address the issues of climate change. India is currently witnessing a spate of constructions, and a large number of buildings that are coming up are residential in nature. And these upcoming residential buildings will soon be the largest electricity consumer in the nation. Thus, it becomes critical that along with the commercial buildings, residential buildings are also constructed to be energy efficient. Residential buildings that are designed and constructed to conserve energy and maintain optimal thermal temperatures have multiple benefits, including cost saving, comfort, and reduction of building footprint. These new buildings will be better for inhabitants and will be better for the planet. As a first step in achieving this by mainstreaming concepts of energy efficient building design, Ministry of Power and Bureau of Energy Efficiency, with the support from Indo-Swiss Building Energy Efficiency Project, are launching a series of special knowledge products under the Energy Efficiency in Buildings program. These knowledge products focus on tools, techniques, technologies, and concepts that a range of stakeholders such as architects, engineers, building professionals, construction engineers, media personnel, and others can refer to. Some of the knowledge products that we are launching today are building heat transfer, understanding through numerical examples publication, tool Vayu Prava, an open form based software tool on computational fluid dynamics, external movable shading systems manual, and building envelope solution sets for Econivas Sanhita 2018. These knowledge products are a critical stepping stone towards paving the path towards low carbon emissions. We are confident that these knowledge products will be adopted throughout the country and beyond. Next, we have a series of presentations. I invite Ms. Varnika Prakash to start the session. Thank you.
Thank you, Akansha, for the welcome address. So now we will start with the technical session. So the change in program is such that we start with the first technical session on building envelope solution sets for residential buildings. This will be followed by a short inaugural session, followed by a session on the media engagement program. We will then have the dignitaries from MOP and DE join us for the launch of the knowledge products via video conferencing. And then we will move on to the last technical session on heat exchange and ventilation in residential buildings. So starting with the first session, I would like to invite architect Ashok Lal, a prominent practicing architect from Delhi. His practice specializes in environmentally and socially sustainable design. He has researched and written on the subject of sustainability extensively and has been involved with architectural education since a very long time. He has also been associated with the Indo-Swiss BEEP since its inception and has been one of the key members in contributing the building envelope solution sets. So, Architect Lal, please.
So Varnika, in order to move this forward, I just have to press this. Yeah. Okay. Thank you, Varnika. As part of the Eco Niwas Samhita, which is the building code for residential buildings energy efficiency, it's a very simple code. It focuses on the properties of the external envelope of the building, because it recognizes that it is the external envelope of the building that modifies the internal conditions of a home in relation to what is variable outside. And so the properties of the external envelope are very critical. And what it does is it gives a certain objective formula for calculating what is called the RETV. It is the rate at which there is an exchange of heat between inside and outside through the external envelope of the building. So the solution sets that I'm going to briefly go over are a kind of a ready reckoner, you can say. It tells you how you can build the different parts of your building, its roof, its walls, its windows and shading, in order to achieve the required performance as given in the RETV requirements of the Eco Niwas Samhita. Eco Niwas Samhita is now popularly referred to as ENS. It's the Residential Building Code. Can you use this? Yeah, thank you. So these solution sets, just to repeat, facilitate compliance with the Eco Niwas Samhita. They give options of wall construction, roof construction, and suggest a simple method for external shading of windows. They provide a brief description of the construction assembly, its construction drawings, the steps of the construction process, which is very important, and an analysis of cost. Seen together, they provide options of different combinations of wall, roof, and window shading. These combinations are generated, are designed so as not to exceed the residential envelope transmittance value, RETV, which is required by the code. That's the objective. So we look at the external wall. I'm afraid you might find that some of the drawings are a little too small to be able to see them clearly, but I'll explain them to you. What's happening today is that there's a large movement in the direction of monolithic concrete for the external walls, particularly of buildings, especially when they get tall. The builders are finding it convenient and quicker to go into this form of construction. But when we run the RETV calculation using that technology, we find that it doesn't suffice. You're not able to meet the ENS requirement. So accepting that you may have to build with reinforced concrete as an external envelope, we have worked out what you must do. What you must do is add an insulating layer on the inside of the building. And the thinnest way of achieving the required performance or a better performance is to have, let us say, mineral wool fixed onto the inner surface of the wall, protected by a boarding. Could be any kind of boarding, it could be a plaster board, it could be a block board, or any kind of boarding from the inside. And this substantially enhances the transmittance value of the wall. If you don't have it, a lot of heat will come in and the wall will store a lot of heat, which will then radiate indoors and make you very uncomfortable. So this is just to say that if you are thinking of going ahead with reinforced concrete wall, for external walls, you should think of insulating from the inside in a simple way. The other popular method of construction is to do a wall on the outer face of the building, which is made out of brick, common brick, burnt brick. Often, the codes require that the wall thickness should be at least 20 centimeters thick, or 230 millimeter, 20 centimeters thick, or 2.3 centimeters, or 20.3 centimeters thick. So it's like a 9-inch brick wall. Now the brick wall also, if it is exposed to the outside, actually conducts quite a lot of heat, stores a lot of heat, and in the evening and through the night, it'll start radiating that heat to the inside. So once again, you need to modify that property of the wall. So what we have suggested in this example is that if you use only a half brick wall on the outside, 115 millimeters thick half brick wall on the outside, and inside you would use insulation in the same way as we had used for the concrete wall. So you don't increase the thickness of construction, but you modify the performance of that wall, modify the thermal behavior of that wall towards a better end. So this is that example. Another way of doing this, if people feel that the occupant will not feel comfortable with the boarding as an inner surface of your wall, or kind of a board, and you might feel, oh, you'll knock on it, it'll sound hollow, and people will say, oh, it's not a pakka construction, it doesn't work. Although there's nothing wrong with it, mind you, it's perfectly okay. But still, if that's the perception, and people feel that they should be able to drill holes and hang cabinets or whatever on the wall, then another solution is to use a two-leaf construction where the external wall can be brick, 115 millimeters thick brick, and the internal layer can be a thin 100 mm AAC block, autoclaved aerated concrete block, lightweight, which conducts much less heat. This doesn't give you quite the same benefit in terms of heat transmission as the earlier example with insulation, but still it does improve it. So that's another way of going about it. Well, you can, if you really want to do a good job, I mean a good job, then this is a traditional method that was used all across Europe, by the way. You had two leaves of wall with an air gap left in between. The air gap used to be the insulating gap. Now, if you fill that air gap, now the insulation material that can fill in that gap is quite economical. So if you have two leaves of wall with insulation sandwiched in between, you get fantastic benefits because you get very good thermal mass, you get a very pakka construction, and you get very good thermal performance values as a result. Bit more elaborate to build, but if you can train your masons to do it, right, and you can tell your buyer, your prospective user, the benefit of this construction, all right, then it's a plus solution. There are other, I mean, this one, I think, have I gone back? Have I moved forward or gone back? I think I've gone back. I pressed the wrong button, is it? Yeah. Oh, it's repeated, maybe. I'm going back, sorry, lost control. Wait a minute. This is the cavity with insulation. This is the one with the brick wall with AAC block. This is the next option. Now, the aerated, autoclaved aerated concrete block is now becoming quite available in various parts of the country. One has to be careful that you buy the right quality of this block that is dimensionally stable, does not absorb too much moisture, and has the compressive strength and compressive integrity that a well-made block should have. So some companies are doing a good job. Some companies are not doing such a good job. And because people tend to buy the cheaper stuff immediately from companies that are not doing such a good job, they say, oh, there are too many complaints and it cracks and it this and that and so forth. So they give up this idea. But actually, as a material, it's jolly good. And if you get the right quality, it'll serve you very well. I can tell you from my own experience, we've used it in many projects, buy the right quality, and it does extremely well. So here you can use a 200 millimeter thick concrete, aerated concrete block as the external envelope itself. Very simple, single operation of construction, very quick masonry, very little finishing work required inside and outside. So this perhaps is going to be the dominant enclosing method that we'll see in times to come. And new materials are also on the horizon. There's a company in Kerala that is making hollow clay blocks now. There's another company in West Bengal that is going to invest in the same technology. This, in terms of the carbon footprint and the use of very abundantly available alluvial soil resource in various parts of the country, it's an excellent product from a sustainability point of view, and it has much better thermal properties than the solid brick. It's lighter, therefore it results also in saving on the structural cost of the building. So similar to the AAC block, you have the hollow clay block, which is coming into the market. And if you ask for it, there'll be more production. When there's more production, it'll become more economical. So I really recommend this as a good solution. Coming to roof. Well, the roof gets the brunt of the heat of the sun. When the sun rises up into the zenith, it hits hard on the roof surface. And if the roof absorbs all the heat and then transmits it later in the day into the room, the top floor becomes unbearable. And I'm sure many people who are listening to this, wherever you are, can vouch for that. Top floor problem. Why? Because the roof is not built properly. The roofing is not done properly. So simple solutions once again. Principle is that the rooftop must be a hard-wearing, light-colored thing. Now there are very good paints. There are light-colored tiles. A broken china mosaic is a common solution. A surface that will reflect off the heat of the sun. Much of the heat of the sun or the rays of the sun are reflected off, so that little of that energy is absorbed in the mass of the roof. That's followed by filtering. Okay? And then you have so there are two examples. You can use lightweight concrete. You can use lightweight concrete as an insulating layer, or you can use many other kinds of now insulating materials that are available. So we've just done an example showing how that can be done. These are the two examples. The last section that I'll go through rather quickly is about shading windows from the outside. Very, very important principle. As you know, the sun is the source of heat. Windows must be there to get ventilation, view, and light. First, you must make sure that the windows are not oversized. They should be adequate for daylight and ventilation. And of course, you must capture the good view when you have it. But if the sun falls directly on the glass or enters through the glass into the room, then that heat is trapped inside the room. Because once the shortwave radiation enters the room and is absorbed by the surfaces and the mass of the building, it is re-radiated as long wave radiation. And glass is opaque to long wave radiation. So the heat gets trapped. This is what we call the greenhouse effect. So it makes no sense to say that I'll have blinds on the inside. It makes no sense to say that I'll have curtains on the inside. What you must have is a shading system on the outside of the building. Of course, how much shade you need, what kind of shade you need, depends on the direction in which you're facing, which your window is facing. Because if it is facing the morning sun, which is rising vertically, or the afternoon sun, which is setting down vertically, as against facing north or south, when the sun rides over the top, and just a mere horizontal projection can give you protection from that sun, you need to devise different kinds or different types of shading as you face in different directions. So you see a very simple suggestion here. The suggestion is that you make a box frame out of steel pipework, fix it on the outside of the window, give it an overhang, give it a cover at the top. It can be any material. It could be a board, it could be a stone, whatever. Just something which is light, not very heavy, and resting on this frame. Now, this frame is the device around which you can attach any additional shading membrane. And I won't go into the details, but I'll show you. There's some images on the bottom left of this sheet which show you how people have attached little chicks or placed planters inside that box to protect them from the direct heat of the sun. So depending on the direction that you're facing and depending on where you are located in the country, because the sun's position and the movement of the sun in the sky varies according to your latitude. If you're in a southern latitude, you'll find that the sun is moving further up in the sky. If you're in the northern latitude, the sun is moving more to the south in the winters. So depending on the solar geometry, you need to attach the shading system onto this frame. And depending on the direction in which the window is facing, you can attach any kind of membrane onto this frame and thereby achieve the required shading. When you're facing directly east or west, let me show you that. I mean, there are many examples, but when you're facing directly east or west, that means I'm facing east, the sun is rising. Early morning, shortly after it has risen, 6 o'clock or 6:30, it's quite nice to have the sun come in. The moment it's more morning time, it starts troubling you. So what do you need to do at that time? You need to lower a shading device against the sun so that it can filter the light, cut out most of the sun, still get some daylight in, and allow ventilation to continue through the window. So what we are talking about here is a movable external shading device. The old chick is a simple way of doing it, but now there are better systems being made available. So when you're facing east and west, movable external shading systems is what we are talking about. And I believe that in the next 4 or 5 years, there's going to be a range of products available in the market, which you can operate from the convenience of the inside of the space or from the window itself to arrange the shading according to the time of day, according to the season. And that will be the truly effective protection against overheating of homes. So just to sum up, these are only some examples which can be directly adopted. We've tried to make these examples such that whatever you are doing today by way of building practice or design practice, you need to modify it only somewhat, not too much, and still move in the direction of meeting the ENS requirement. The RETV does not prescribe, sorry about the spelling error, does not prescribe any particular construction material or configuration of wall or window. It's not a prescriptive code, it is a performative code. And so there will be many other solutions than those that have been mentioned here, given here, that can be devised to meet the RETV required by ENS, or even do better than what is required. And that's the direction in which we should be moving. Thank you.
Thank you so much, Lal sir. We'll take questions at the end of the session. So yeah, moving on to the next presentation. So the next presentation is by me. It's on external movable shading systems. And I think Lal sir has already mentioned quite a bit about the importance of external movable shading systems in construction, particularly residential construction. So now the thing is that when we look at urban residential buildings and the typical window design that goes with it, there are recent trends of very large floor to ceiling windows that we see in both residential and commercial buildings, and this is particularly true of high end residential buildings. And so the concept is that the better buildings you have, or the more affluent you are, the bigger windows you have. That is the norm that we are seeing these days. And you have these large windows if you talk of residential buildings, in your bedrooms, in your living rooms. And the truth is that they may or may not be they don't need to be so big. So and it is sold based on the fact that you get better views if you have bigger windows. But the fact is that even if you get better views, you also get excessive heat and excessive daylight coming inside your building, and that is something that needs to be taken care of. However, if we look at old Indian homes, that has not always been the practice. So here we have a couple of images from Calcutta, Kerala, Rajasthan, Delhi, Rashtrapati Bhavan, Pondicherry, Ahmedabad. So you see, various geographies. But what you see here is that, in all these geographies, yes, there are windows. Some of them may be bigger or smaller, but they all have shutters of some kind that are, that is protecting the excessive heat that is going inside. So we can say, and even today, if you go to these buildings, you always feel very comfortable despite the excessive heat that might be there outside. So you always feel comfortable. So definitely they were doing something right at that point in time. And we see that, these shutters and different kinds of shadings started to disappear from the construction scene around the 1960s, when we started to modernize our buildings. So in the race for modernization, we forgot a few indigenous architectural practices that were there. And it has been scientifically proved also that external movable shading can reduce 80 to 90% of the heat ingress that comes in to the building through windows. So there is a report by LBNL that also states that. And apart from that, BEEP also recently conducted a study. It was a real life experiment that we conducted, where we had taken two identical flats on two floors of the same building in NCR. And so it was a 4 BHK flat, and then we took one room as a sample, as a sample room where the testing was carried out. That room had sliding doors, and it had a WWR, that is the window to wall area ratio, of 58%, and was west facing. One room had an external shading MSIS installed on it, while the other had a regular internal curtain. And we tested it for two scenarios, that was for natural ventilation as well as for an air conditioned case. And what we saw over a course of 2 weeks monitoring patches in March and June was that there was a significant decrease in the internal temperature for the naturally ventilated case. It was roughly 3.5 degrees in the inside operative temperature. And in case of the air conditioned case, there was a cumulative difference of a reduction of 32% cooling load. Here are a few pictures. So the white, this thing that you see is sort of an external blind that was put outside the window. And this is an internal curtain, a regular cotton curtain that we generally have. And here you can see the monitoring setup. Now, we have established that MSIS definitely has a potential to reduce the heat ingress. Now, coming to the types of external shading that is available in the market. So we have regular shutters, quite similar to the ones that were used in old buildings earlier. There are vertical screens. So the most common example is that of a bamboo chick that we have all seen in different kinds of buildings. And so the vertical screens also come in different materials. In fact, the product that was used for our performance monitoring testing was also a vertical screen, a modern version of it. There are retractable awnings. Then there are vertical louvers of different configurations and lamella blinds. The publication that we are going to launch today, the MSIS manual, currently covers the 3 categories of shutters, vertical screens, and retractable awnings. Now, coming to louvered shutters. So there are different types of shutters. So there are adjustable louvers, there are fixed louvers, and then there are adjustable louvers in different combinations. There are different kinds of materials in which these shutters are available, primarily in wood, PVC, and aluminum. You can also see the anatomy. So once you receive the manuals, you'll see all these details in it. So I'm rushing through it right now. Now, how these shutters are operated. So here you see an example of a top hinge. There are different ways depending on the need of your building that these shutters can be mounted. So here is a top hinge. Then you have a sliding shutter. You have a sliding folding shutter, the regular hinged shutter. And then you have the lever operated shutters, which also have different mechanisms on how the louvers can be adjusted. The vertical screens, again, so now we have a clutch roller blind. These are quite similar to the internal blinds that we have. The difference in these blinds is primarily that because they're mounted outside, the mounting mechanism and the materials have to be resistant to excessive heat, rain, dust, etc. So they have to be more robust. So this is a clutch roller, this is a zipper track, more useful particularly for high-rise buildings or where the wind velocity is really high. The Venetian blinds quite similar to the ones that are used inside, as well as quite similar in performance to the shutters. The typical roll-up blinds also used mostly in chicks, outdoor curtains, and Roman fold blinds. So all these things, I think this is one category which is very similar to the kind of shading products that we use inside. So instead of curtains, a lot of us use these kind of products. And it's very easy to, just use these outside a building with a little bit of difference. So here, the most important thing is the main cassette where the the blind is sort of mounted on. That's the most important part. And then there are different side tracks, or there are cables that sort of hinge it to the ground, etc. So there are a wide variety of materials for the blind per se. And the frame material is particularly that of aluminum, stainless steel, PVC, etc. So there's a wide array, and the cost also mostly depends on the kind of material, the kind of porosity, the kind of the heat that can come in. So you would have like a 40%, 60%, 90%, etc. So here you can see different kinds of working mechanisms. So there's a crankshaft, there's a cable guided, the regular cord stringed, the zipper tracks, the Venetian, the cord locking, curtain channels, and Roman folds. So like I said, there are a lot of details to it on what suits your needs. And these can be mounted both outside the building as well as in balcony application. They can be wall mounted, they can be ceiling mounted. You can also have a groove in the ceiling, and they're easy to mount and just be used. So the different kinds of blinds that we had, the Roman, roll-up, Venetian, etc. So here you see images of that. Coming to retractable awnings. So this is something that most of us see in a lot of European cities, and it is very significant of the cafe culture. So they're generally colorful and look quite attractive. So the different kinds that are available is a pivot arm with a valance. So there are different minor changes to the products. The regular foldable arm that we have seen in most cases a quarter round circular type. Here again, the most important parts are that, where the cassette where the awning is mounted on to the wall or to the ceiling, the working mechanism, that is the shaft or the roller or whatever you're using to bring it down, and the arms. So those could be pivot arms or those could be folding arms, whatever. The material again, so there are different kinds of materials of the fabric. So there is a PVC available, acrylic available, and the cost also depends on the kind of material. Different materials have different, longevity also. The material in terms of the frame and the main structure of the awnings is generally aluminum, or it could be mild steel in some cases. So here you see images of how different kinds of awnings work, and these are some of the most common ones that we have seen. These again are used mostly in balcony applications or even non-balcony applications, but the most crucial thing is that they are not very suitable for high-rise buildings as their wind tolerance is quite less. So generally they are not used for buildings more than 3 floors high. These again can be mounted on the ceiling and the wall, and you see different kinds of applicability here, of the different kinds of awnings. And if we do a comparative of, the properties and the cost of, all these products, then what we see here is that the shutters definitely are a win-win because they give us best protection against the heat. They have best wind tolerance. They are expensive, but their lifetime is also very long. So it's like making an investment, for a really long period. The vertical screens do provide good protection, and their lifetime is generally, a medium lifetime. They are slightly cost effective, and their wind tolerance is also fine. So in terms of the Indian scenario where we are a very, the cost matters a lot to us, I think vertical screens is something that can be used extensively here. The awnings, so because they're not as effective in terms of, solar heat gain coefficient, and their wind tolerance is also low. So these have a limited application, but the most widespread application is that of vertical screens and shutters. So I would say the best option for India would be vertical screens as of now. It's quite easy to maintain most of these products. They are generally, with a mild detergent or dry lubricant. So just vacuuming these can be fine. So the myth that you really have to invest a lot in the maintenance, etc., or put in a lot of effort, that's not really true. So if we say, it is now proven that, external shading can provide, reduce the indoor temperature by almost 3.5 degrees. And it in turn reduces the need for air conditioning, as we've seen, to almost 32%. And then in turn, it reduces the CO2 emissions and GHG emissions. And at the end, the restoration of the ozone layer when we talk of the larger climate change goals. So it is definitely a win-win situation for all. Just a matter of putting a little more extra effort of using a system like this. So thank you so much. So the next presentation is by architect Divya Talwar. Divya Talwar is an architect and urban designer in the affordable housing domain. She's an architect and holds a master in urban planning from the School of Planning and Architecture, Delhi. And she has been working on a variety of projects related to sustainable affordable housing in India. She is currently working with the GIZ, and she has been a key member of the team that worked on developing the catalog for replicable designs in India. So, Divya, over to you.
Thank you, Varnika. Hello, everyone. I am here to talk about the catalog of replicable designs for energy efficient residential buildings. So this is a joint collaboration between GIZ and Bureau of Energy Efficiency. So the catalog is basically designed for immediate impact to be adopted for the housing stock that is yet to be built. It has some simple energy efficient designs and measures that can be adopted at different stages in the building. It is focused on providing relevant information on sustainable buildings in an easy to use format for a variety of users ranging from builders, designers, homeowners, and the government agencies who are working on policy as well as in providing housing. So the catalog basically caters to various residential types. It covers different house sizes and it addresses the needs for various zones in the country in terms of the climatic needs. The catalog identifies 5 representative cities, which represent each climatic zone, and the results for the energy simulations and performance are mapped in the catalog accordingly. So what are replicable type designs? These are not just ready to use templates, but they're also a learning mechanism to encourage users to learn from the step-by-step improvement to the building envelope and adapt it and adopt it to their specific needs and requirements and their cost constraints. These designs ensure energy efficiency through passive design measures, the basic principle of preventing heat gain for warm climates and making the most of solar gains for cold climates. They also work with low energy structure and materials that have a good thermal impact, and they enhance the thermal comfort with the use of efficient mechanical systems when required. This entire project was carried out in 5 stages. So the first stage began with the identification of the residential typologies that are prevalent today in the country. The second stage was developing the type designs for each of these typologies identified. Going on to identify the material specifications and the suitable structural systems that can be adopted to support these designs. The final stage was assessment of these designs in terms of energy performance, daylight simulations, and doing a techno-commercial feasibility analysis in terms of cost benefit. And lastly, to present it in a form that is usable by a wide target group in the form of web tools or catalogs. So I'll take you through these 5 stages briefly. Understanding the residential typologies. So when we talk about the basic dwelling unit, and as we expand it horizontally and vertically, different typologies and configurations can be mapped. The tool targets 2 sets. Firstly, the single family homes that are the plotted type. The configuration changes as the plot size increases. So for smaller plots, you have units that are adjacent to other units on all 3 sides, with majorly the front being open to light and ventilation. So you have the back-to-back row house. As you go bigger in plot size, you have the 2-side open row house that you can see in the bottom of the screen. As the plot size increases, the need for setbacks also changes, and you have the 3-side open row house, or the semi-detached unit as we call it. For larger plots beyond 300 square meters, we have the standalone detached, which is open on all sides. So as the number of exposed sides keep increasing, the compactness of the unit changes, and therefore the energy efficiency measures that need to be adopted also change. The other category is the multifamily or the group development, the apartments as we know. Here also different typologies are more suitable to different types of sizes. So the smaller sizes, the 3 to 4 story walk-up apartments work well with the row house typology in the back-to-back or 2-side open format. As we go to mid-rise range, we look at a more linear format with the help of corridors. So there'll be singly loaded or doubly loaded corridor typology. And as the unit size grows beyond 100 square meters, you have the tower typology, which works well, going into the high-rise format with the central core and 4 to 6 units served by the core. The apartment typology generally offers a better compactness because the exposure from the external walls as well as roof and bottom floors is limited. The other categorization in the catalog is in terms of the strategy. So majorly the strategy is divided into two zones. One is for warm climates and the other one is for cold climates. So for warm climates, the basic design principle starts with compactness, limiting the exposure of the envelope, then modifying the envelope to improve the shading, the thermal mass, the insulation, accordingly choosing materials, designing the openings for adequate ventilation and daylight, and then limiting solar access through shading and projections. These can then be supplemented with the mechanical means when required. For the cold climates, solar gain is essential. So the main design feature in cold climates is having sun balconies close to the living spaces so that the solar radiation can be made use of and passive techniques can be sufficient for the heating demand. After the design, moving on to the construction methodology, the catalog adopts a simple structural system using existing and prevalent technologies, a simple system which is economical for residential construction, keeping to a 3 to 4 meter grid size. The standard modules are developed such that these bays can be repetitive and lead to different configurations of the residential unit. So you have the same system leading into a 2-bay, which is a 1 BHK, to a 2 BHK with 3 bays, and developing into a 3 BHK with 4 bays. Simultaneously looking at construction methodology in terms of materials and other elements. So starting with the very basic brick construction, going on to simple RCC frame, but replaced by lightweight blockwork infill, then adding on insulation for better performance. Similarly for windows, looking at shading devices and looking at simple rolled steel sections with single glass, going on to UPVC with double glazed windows. The next step is talking about the energy performance. So the catalog is a stepwise improvement. So you have the basic base case, which suffices with the standards as provided in the ENS, and then goes on to improved energy performance over 3 stages: moderate, good, and high, which are developed through improved material, improved insulation, and improved window configuration and shading. Some examples go on to an exemplary passive house standard, which depict the need for global standards of comfort and air quality within the unit. This may need to adopt higher level of technologies, which may not be cost efficient today, but will lead eventually towards net zero buildings. Then when we talk about simulation and energy performance, these are done at unit level in the catalog. So each unit behaves differently based on its orientation and its location in the building, because the exposure is also different when you talk about an edge unit or a unit which is exposed on the roof. So the location of the unit defines what the energy performance would be, and accordingly the measures are depicted. The catalog identifies 6 key performance indicators across which these units, the design options can be compared and the performance can be measured, so the user can make an informed decision. The energy performance is done in terms of energy simulation using Design Builder and Energy Plus software. The design files are all available as part of the web tool. Apart from thermal comfort, visual comfort is also mapped in through the daylight performance. These values and files are also available as part of the web tool. Lastly, looking at the deliverable of the project, we have the replicable design tool, which is available on the EcoNivas website, as well as the handbook. The handbook additionally records the learnings and trends seen in the project and the larger objective of achieving energy efficient residential buildings. Whereas the web tool talks about each and every example and its energy performance. The structure of the web tool is pretty simple and easy to use. So it starts with identifying the location that the user is interested in, going on to select the typology that is suitable for that location, and then identifying the unit type and size of interest. Once you identify all of these, it gives you a detailed information on the working drawing set for that particular design, as well as the performance set for different levels of energy performance. All these files are downloadable and can be used by the users for further working or adapting the design to their required specific locations. The next few slides take us over the interface of the web tool. So you begin with identifying the location, identifying the climate zone. And you are prompted with the typology that the climate zone offers under multifamily and single family homes. Here you have a range of sizes and typologies, designs that are available. Once you choose the design of interest, it gives you the sizes and configurations possible. This leads you to the master set where you can select the location and orientation of the unit. Here you will be able to download all the detailed working drawings, the Revit models for further working. You get details of how the installation of the shading devices can be done, the working drawings in terms of plan sections, elevations ready to execute. You also get a detailed BOQ. You can go further and delve into the energy performance and different aspects of energy indicators through the tool, looking at daylight performance, energy performance, and heat gains. All these simulation files are also downloadable. So I encourage all of you to just have a look at the tool at the EcoNivas website, and it's pretty simple to use and interactive in nature. Thank you so much.
Thank you so much, Divya. Now I would request all the panelists to come here for the Q&A session. And I would also request Dr. Sameer Maithil to join us on stage.
Good afternoon, everybody who are physically here, as well as people who have joined us through both on YouTube as well as on Zoom link. Now, what we have heard from our three speakers really covers a broad spectrum of solutions which exist today, both at the initial construction stage, what we can do to meet with the in a sense, compliance with EcoNivas Samhita, or more broadly, how to construct thermally comfortable and energy efficient housing. Then we have also heard a little bit about solutions which can be used for retrofitting of buildings also. What Varnika presented about external movable shading systems. So those are also retrofit solutions. And at the initial construction stage, we have looked at various building elements, what can be done, as well as overall how the building should be designed, what Divya presented. So that way, I think we have a good set of solutions which have been presented. So we have around 10 minutes for the question answers, and we have receiving questions also on through our sort of on the web. So I will first start with a question which Adarsh Jain has asked to Lal sir. It is addressed to you. Any suggestions for enveloping of existing structures? So I think he is talking about retrofitting existing housing, and particularly for walling, and like you can cover all the elements.
Can you hear me? Yeah. That's good. Well, I think as Samiji has just pointed out, that if you are already living in a home or somebody has already built something which is not comfortable and requires too much air conditioning to remain comfortable, then there are two things we can definitely do. Walls, the outer walls that are exposed to the intensity of the sun, we should find a simple way of insulating them from the inside. That's one thing we can do. It is doable. It's just a matter of 2 inches thickness that you might lose on the external wall only. Okay? That's definitely worth doing. The second is, as Varnika pointed out, choose an awning, choose any other kind of shading system that can be installed outside the window to cut out the sun that is not wanted. Just these two actions can significantly improve the thermal comfort within your building. If you're on the top floor, the most effective method is to get your neighbors or yourself to pool in and put in, just redo the roofing, add some insulation and a reflective surface on the top. So these are all actions that can be done for retrofitting and can significantly improve the thermal conditions inside.
So if there are any questions from the audience here, we can take it, and then I will move on to few more questions which we have. Yes.
I have a question.
Yeah. So please use mic so that our online viewers are also.
Right.
And you can also introduce yourself.
Yeah, good morning. I'm VK Srivastav. I'm consultant refining sector with B. I have a question from Mr. Lal. India being the temperate country, is the solution given by you is good for all the main seasons? Number one. Number two, how much it is going to aid the cost of the building? Normal construction we service this thermal envelope construction.
So as far as the climatic condition in India is concerned, it varies considerably across the geography of the country. We have 5 climatic zones which are quite distinct one from the other. So the performance required of the external envelope of the building in ENS is climate zone specific. It gives you, for the warm humid climates, one number, for the other climates another number that you have to satisfy. Yes, the construction technologies that we're talking about might add a 2 to 3% extra cost on the construction of the building. Mind you, if you look at the sale price of any home that you go out to buy today, 60 to 70% of that sale price is attributable to the distribution of land cost, its locational value. The construction cost going up by 2, 3, or even 5% is negligible. It can never be an argument for not doing the right thing. Second thing, sir, is very important, very pertinent to your question, is that 5 years ago, 7 years ago, people would say, we don't know what to do. Tell us what to do. Tell us how much it will cost. Now we have done a number of exercises which show you so many examples of what can be done, how it can be done. This is now becoming available to the public at large. Very soon, in the next year or two, it will no longer be the builder's market. It will be the buyer's market. The buyer is going to ask for what the buyer knows he deserves. And therefore, this is a message to designers and builders. Just do the right thing, satisfy ENS when it comes to residential buildings.
Yeah. A very good morning to everyone. Myself, Anmol Mathur. I'm a building physics consultant and I've been working for the last 1 year with many developers on housing projects. So first of all, I'd really like to congratulate BEEP for the exemplary work that they have been doing, not just now, but from the last very few years, and really bringing out conscious decisions that how builders and developers should look at the housing sector. My question to the panelists is that, as Lal sir, you just pointed out that very soon it will not be a builder's market, it would be a consumer's market. But if I talk about today's reality, it is still a builder's market. And even that 1 or 2% of extra cost is something that they're just reluctant to invest in. And the only two things that developers are skeptical are about the time of construction and the cost of construction. And occupants' health and occupants' energy consumption is something of least concern. So with that, is there any kind of a tool or something in terms of literature available in the public domain that can actually help bust these myths of the developers? And also something, it's a suggestion from my side that if something could be more, circulated in the public domain towards the buyers, so that they also start understanding these things. Right now, all these technical documents, all these tools are very complex for a home buyer to understand that what is the value that he's going to invest, what is the price that he's going to pay, not only for that particular house, but eventually in the life cycle, how they will end up consuming energy. So is there something that is being done in this side? I would really be interested to know about that.
I think we will take the other question also, and then I will, because we are a little bit short of time. So let us take the other question also, and then I will ask the panel.
Yeah, very good morning. I am Dr. Binod Kumar Singh from School of Planning and Architecture. So I have question with Mr. Lal that recommendation of half brick wall may pose problem for the structural stability during the earthquake.
I think Lal sir. No, first one I think is a question which we will also be addressing in the media session. So I will like that we discuss it more about this in that session, if you allow me to do that. But you can answer the second, the technical question.
So it's a very simple thing. We're not talking about only half brick. It is a 2-layer wall in which there's an internal layer of an insulating blockwork and an external layer, which is the brickwork. And they can be tied with plastic strips in between. And then it is very simple. Every fourth course, you put in a 6 or 8 mm reinforcement, which you can tie into the structural element, the vertical structural element. So it can be very safe as far as the earthquake integrity of the building is concerned.
Thank you.
Can I ask one question?
Yes, please. Last question for this session.
Okay, this is Archana Jyoti from Pioneer newspaper. I want to know, like Lal sir said that, soon consumer will be the king in the green efficiency residential building. So I want to know, meaning on what basis you are seeing, because it's long time, and otherwise also basically it's the builders who are dominating the sector. So on what assumptions, or is there any, government's plan, or on what basis you are, saying that consumer will be the king in the sector?
Okay, you are the person on whose basis I'm saying so. You are the person who takes the message to the public. You will not advertise any builder product on your newspaper unless it mentions its ENS properties. Thank you.
Okay, I think I have one question for Varnika also. which was there, which is little bit similar that you have told about various new sort of solutions which have come into the ground. I think the challenge there is also how do we educate how we take these materials. Generally, the companies who are manufacturing these products are quite small, so they do not have enough budgets for advertising, etc. So how do we educate the users that these products are available?
So I think if I don't focus on the technology per se, that is external shading, and we look at the larger message, and again, like Samir also mentioned, we're going to address it in the media session. The whole point of having a media engagement program, I'm coming to that, but was to have a general messaging for the public, wherein you highlight key features that they really need to consider while either building or buying a home. So, while there are different technologies, different products that are available, I don't think we can, expect the consumer to suddenly be aware of, one or two or so many different products just because we belong to that industry. So a gradual messaging has to go, and once they realize the fundamental that they need to be aware of, they will automatically look for different products in the market that are available. So I think the general messaging is more important for the end user rather than being fixated on the type of product or the type of material that they should use.
Okay, we will be ending this session, but just to tell the audience that the first two presentations, what was presented, would be available today when the knowledge products will be released. So we have the printed copies of these documents, all the information which was presented, as well as it will be made available on the net. What Divya presented is already available on the net. Yeah. So all these catalogs and the tool is already available. So all the information will be publicly available.
Yeah, so we'll just present mementos to the speakers and then we'll break for tea. Thank you.
While we are getting the mementos, I want to ask Divya one question. Divya, will you be there if someone contacts you on the GIZ website to handhold and train anybody who's interested to go through the website or encourage them to do so? Will you be there?
Definitely, and we are starting a lot of programs which deal with capacity building, and please keep a check on the website so you will have some news of upcoming events, and I'll definitely be there.
Oh, sorry. Photograph. I thought you had to wear a mask to take a photograph. You should go there.
So we'll break for tea and then come back in 10 minutes. You can also get your tea, coffee inside if you want.
I think that would be
Yeah.
nice. Like you can maybe take tea and coffee and maybe bring it inside so that we are able to start in 10 minutes. Thank you.
Request all participants to please take their seats. Tea, coffee inside. I will request everyone to please take their seats. So we now move to the inaugural session of today's event. I would request Dr. Ashok Kumar, Deputy Director General, Bureau of Energy Efficiency, and Dr. Jonathan Demorge, Head of Cooperation and Counselor, Swiss Agency for Development and Cooperation, to please come on the stage. I will also request Dr. Samir Mehtil to join us on stage. Dr. Ashok Kumar is the current Deputy Director General of BE. He has primarily been involved in the implementation of the National Mission on Enhanced Energy Efficiency, the NNEEE, a component of National Action Plan for Climate Change of India, among other responsibilities. Under the mission, he is involved in the coordination of the Perform Achieve Trade, the PAT scheme, the flagship program under the mission. He also heads the R&D related activities for BE for accelerated market transformation for energy efficient appliances. Dr. Jonathan Demorge is the Head of Cooperation for the Swiss Agency for Development and Cooperation in India. He is trained as an anthropologist and holds a PhD from the Institute of Development Studies in Political Ecology. He has worked for the Netherlands Development Organization, the Overseas Development Institute, various NGOs, and as a researcher in Nepal, India, Kazakhstan, Ethiopia, and West Africa. So I invite both of you to this event. Thank you. We will now give mementos to our dignitaries. Photographer. Photographer. I will now request Dr. Ashok Kumar to give the address.
Good morning, Dr. Jonathan Demang, Dr. Samir Mathal, experts from building sector, officials from SDAs connected online, and other participants and friends from media. So it is a pleasure for me, and possibly I would be the least educated in the building sector. So that just to, I would not focus into the technicalities of the building sector's topic today, but I would just emphasize on a larger context for which, these particular interventions of efficiency comes in handy. So just to put ourselves in a context that we as a generation is now at a crossroad, as you know that we have an existential problem. Our, the sustainability, the very existence of human society is now threatened because of doing or possibly our own. So there is a challenge of how to continue the way we have lived so far in the times to come. So recently, everyone has kept track of what has happened in COP26. What were the discussions? Primarily to address the challenges of the climate that is threatening our very system of the natural course of action that sustains our life. And it is more pertinent for a country like India, which is sustaining a life of 1/6 of the population on a 1/3 of the land with limited resources. So in that context, every action, every small contribution that comes for conservation, saving, any practice, any value system, that is welcome for a country like ours to go ahead with the kind of aspiration that millions still strive for. So that is the challenge for us. And as increasingly what is becoming a narrow lane of negotiation across the one at the resource limitation, and another is the limitation that is caused by the climate itself, the atmosphere. Today, even if you have the resource that has pulled the engines of growth in the 19th century, 20th century, we do not have that liberty to use. We are now being talked about carbon budget. We are talked about the limitations, how much you can use. So within that limited space, we have to negotiate our growth story to the levels that we are aspiring for. And I think building is one very close aspect that touches every one of us. We can relate to building, wherever you are, because we live in a building. So I think that the presentations of architect Lal and other experts here, everyone can relate to, how outside shading, inside shading, heat, cold, everything is so interlinked. So any interventions, for example, when I was listening to the presentation, so the way, the simple shading outside, for example, that I can relate to because I have put myself on the house, a chick, and I saw the effect of that chick on the blocking of the heat. So those are, fundamental aspects. So what I, not getting into the modernity or any aspect of it, but there is a learning, lot of learning that you also have mentioned about the traditional wisdom, traditional knowledge that has evolved over centuries of practicing, experiencing, and so on. And that is how it has evolved. So we need to take the advantage of what we have and then possibly supplement with the technology that is coming from the modern ways of doing things, modern expertise. But certainly, the modern history, for example, what is happening now is in a total contextual, in a whole lifespan of humanity is seen, modern science has been, or the modern technology has been 300 years old. So fundamentally, we also need to look that aspect as well, that the capacity or the potential of the solutions that the modern world or the modern technology can give, possibly that might have certain limitations which traditional technologies might prove more competent to it. But that is up to the experts of August gathering here to look into. But I think we should be mindful of all the aspects. So that is why I was, I think Akanksha or someone narrated the statement from the NDC document, that in the NDC document, statement is that India will have its developmental course, which will be way different than what it has been in the past. Why? Because we are in a situation way different than what the others were there. So India's development story, growth story will be very different, for which we do not have any template to follow. So we have to look into that, how we cannot be a New Yorker for sure. We cannot be consuming, say, how many or tens of MTOE per capita. Just resource is not there. So fundamentally, we have to evolve ourselves in a very light way of doing things, particularly in the resource aspect, so that we can, within that limited resources, we can have a better living standard. Now, how to do that is the challenge. So that is for all of us to ponder upon. So then, again, the presentation, I think one presentation where we showed that the value system, the higher, bigger, more big window is the significance of a status symbol. So those also have to somewhere we have to correct those values as well, so that the smaller window can give you more comfortable life and the comfort that we are looking forward. And that also should be, for example, I was told that in the Hollywood, driving a electric vehicle or a cycling is considered a status symbol. You really raise your collar that I am cycling. But on the other hand, in our context, the person who is cycling, you don't even consider, you don't even right of way to cross the road. So all that fundamentally has to integrate ourselves in the whole system of things. So with that, I think, I would not take much because various good presentations are going to come. So I would just urge and see that various interventions that we are going to discuss, and particularly the publications that are going to release, those are very useful. I see that there are the document, the booklet on the heat transfer, which is going to supplement the engineering students to understand better in a contextual way. So we have learned, for example, I am a mechanical engineer where I have seen a little bit of engineering and how to apply. I have been to a thermal power plant. I looked into the whole cycle, but then still you have a very limited window to look at, but that window has to open, because that building has to sit in some context and perform in some context and satisfy the needs or the comfort of a person who's living there. So depending upon what the expectation is of that person. So for example, architect Lal has said that the user will define the market. So that has to, and the thing that is going to come up in the discussions of the media, that's very important, that's the knowledge about the options. For example, I will not take much time, we did a small study on the decision-making based on the information on a fan, ceiling fans. In India, ceiling fan is very ubiquitous, appliance. There we saw that if the people have the information, that information results almost 95% into the decision. So the problem is there is no information, the lack of information. People do not have the information. People understand, even people are intelligent enough. But problem is, the options are not there, or if they are there in the lingo that they do not understand. So I think the presentations, and I was briefed that is going to be discussed. That will be very useful. So with that, I think I will stop here and thank you for patient listening. And we would be certainly looking forward I am just substituting the dignitaries who are supposed to be here. You would have been much more delighted if they had in the presence of, all of you. So thank you very much for the, your time. And I hope that deliberations of yours here will really, push this forward. And I think particularly the media, the communication part, let this be the start of it. We can take this to way beyond, so that, gentlemen have asked about, how that masses will have the information. So thank you very much.
Thank you so much for your insights, Dr. Kumar. Now I would request Dr. Jonathan Dimanche to give his address.
How do I unmute myself? Okay. This is my first physical conference audience in 1.5 years, so it feels strange. It feels great. I can't see your smiles, but it feels great to be here with you. Mr. Ashok Kumar, Secretary, Ministry of Power, Government of India. Actually, you could have gone on. I think I could have listened to you for hours. It was so important, the message you gave us today. This, Dr. Samir, distinguished guests, dear ladies and gentlemen, it's a pleasure, it's an honor to be with you today. To join you for this important workshop on energy efficiency in the Indian residential sector, but also because we are addressing such an important topic, such an important issue, as it was introduced by my predecessor. The main reason also is that the topic of energy efficiency in buildings is at the very core of SDC, the Swiss Development and Cooperation Agency in India. With the recent conclusion of COP26, and current concerns that global commitments to environmental sustainability should not compromise social and economic development, it's probably the right time that we deliberated upon energy efficiency in buildings. I've been living in India now for 1.5 years and traveling, researching, working for 20 years. But wherever I could travel within the country over these last years, whether it's a big city, a small city, I see giant strides. I see huge changes, especially in infrastructure development, particularly in the housing sector. And it is evident that India is being built now, and that we therefore have the opportunity, and we must make this big infrastructure development in India energy efficient, resilient, and sustainable. Because the decision we make today will have impacts, will have consequences for the next half century and even more. And we are sitting at a crossroad, as Mr. Kumar eloquently said. SDC in India is committed to supporting the government of India in achieving its climate commitments. The program in India focuses on climate change and environment as part of our work on low emission development or mitigation to climate change, where the focus is on clean energy and energy efficiency. One of the core areas of our work is on built environment. The built environment component engages at 3 levels. First, building materials that are used in the construction of the buildings. Second, building design, which is making buildings more efficient, energy efficient. And third, resilient cities, on integrated approach to make cities more livable and sustainable, especially in a changing climate. So our work on building design is part of the Indo-Swiss Building Energy Efficiency Program, or BIP, which is steered and implemented jointly with the Bureau of Energy Efficiency and the Ministry of Power. This cooperation has developed numerous knowledge products and programs on the subject. Most important one is the ECONIWAS Samhita, or ENS Part 1, which has been referred to by Mr. Lal also this morning. This knowledge product demonstrates the true essence of our partnership. Swiss expertise coupled with Indian experience to develop indigenous solutions to achieve energy efficiency in the Indian building sector. So the COVID-19 pandemic has brought to the forefront the need for well-designed buildings that are not just energy efficient, but also healthy for people to live in. And the vision, policies, and programs of the government in this regard are commendable. It launched the Ekoniwa Samhita, the Residential Energy Conservation Building Code, back in 2018. And ENS focuses on the importance of a good building envelope to ensure that optimal daylighting and natural ventilation are provided. It was then followed by the inclusion of electromechanical system in the code to address the mechanical to address the mechanical systems in buildings. We at SDC are proud to have collaborated with the Ministry of Power and the Bureau of Energy Efficiency in this endeavor. The knowledge products being launched today are a step ahead in this direction, as they guide building designers to adopt these practical solutions to achieve the Ekoniwa Samhita benchmarks. So four products are here. The first is the book on understanding heat transfer in buildings through numerical examples. It's targeted towards future building engineers to develop strong fundamentals on the complex subject of heat transfer in buildings. Second, the standard envelope solution sets, which is a support document to the Ekoniwa Samhita, which is aimed at equipping building designers with practical solutions to achieve the benchmark set in the code. Third, the external movable shading as a solution used widely in Switzerland, but also worldwide and in India, as it was shown before. And it's heartening to know that many of such products are available already in India. And we hope that many more will come and that its use will be much more widespread. The compilation of these products in the MSIS manual can come in very handy to building designers to adopt these very effective solutions to limiting penetration of sun heat in buildings. And last but not least, the Vayu Pravah, an open source computational fluid dynamics CFD tool, quite a high-tech tool actually, that is aimed at improving the natural ventilation potential in buildings or blocks of buildings, groups of buildings. I would like to congratulate the Ministry of Power and the Bureau of Energy Efficiency on this pioneering development. This is a free tool, it's in the public domain, a free tool that will be accessible not only to building designers in India, but also to designers in other parts of the world. And this tool is expected to be particularly useful to other tropical countries. So as India celebrates its 75th year of independence, it will also lead the world to energy efficient buildings, which are naturally ventilated. So it's double independence. And as Mr. Kumar mentioned, there is no template for India, but there's also no template for other countries in the world when it comes to sustainability. It's all, I mean, I come from a country that has also to heal from addiction to oil. And like any addiction, it's not easy to do so, right? We all need solutions. And we hope that India can also show the example, can show the way. And we can also liberate ourselves from this oil addiction. So I also congratulate here the BIP team for their hard work to bring in core expertise for the development of these knowledge products. And with this, let me wish you very best for your deliberation over the day. Thank you very much.
Thank you so much, Dr. Dimoj. I think we can now have the photo moment that we missed earlier. So we will move on to our media session, and I would request Dr. Dimoj and Dr. Kumar to stay on the stage. I will now invite Ms. Anu Anand and Dr. P.N. Vasanthi to join us on the stage. Ms. Anu Anand is the editor, Transparency Review, and head of the CMS advocacy team. She has over 25 years of experience in writing about social and development issues for various publications. She has been the team leader for the BEEP CMS Media Engagement Program on energy efficient buildings. Dr. P.N. Vasanti is a psychologist and social researcher and is currently the Director General of the Center for Media Studies. She has recently been elected as the Vice Chair for the South and Southeast Asia of IUCN-CEC and the Commission for Education and Communication. She also leads and implements an innovative program initiative like the CMS Vatavaran, one of the Asia's largest international film festival and forum on environment and wildlife. She's also a member and advisor to various organizations, including Ministry of Environment, Forests and Climate Change, Ministry of Information and Broadcasting, National Commission on Protection of Child Rights, and Advertising Standards Council of India. Welcome to all of you. Sorry, I missed one more panelist, Ms. Archana Jyoti. She is a special correspondent for the leading national English daily, The Pioneer in Delhi. My apologies to you, Archana, for missing you out. Archana is responsible for the full-time coverage and analysis of news reports pertaining to Union Ministries of Health, Science and Technology, Environment, Social and Welfare, Culture, and Tourism. She has also worked for Delhi-based newspaper Asian Age and country's reputed news agency, Press Trust of India. Thank you so much, everyone. And I will now request Ms. Anu Anand to give her presentation, which will be followed by a panel discussion, also moderated by Ms. Anu Anand.
Thank you, Varnika. Dr. Ashok Kumar, Dr. Dimansh, Vasanti, Archana Jyoti. First of all, I am very thankful to the BEE for inviting me to share the experiences of media engagement program and talking about the role of the media in promotion of building energy efficiency. Before I talk about the media engagement program, I would like to introduce my organizations to whom I represent. 1 minute. Next is not moving. Right. Yes. Sorry. Yeah. Yeah, I represent the Center for Media Studies, which is popularly known as a CMS. The idea behind the CMS is to monitor and evaluate critical role of the media in our lives and its impact on the policy, perception, and practice on the crucial development issues. Since our inception of 30 years ago, we have, again, I think there is a problem. I'll move with this. Yeah. Okay, thank you. Yes. Yeah. Yes. Idea behind CMS, since our inception of 30 years ago, we have been studying and also supporting the media for becoming a more relevant to our nation's development agenda. Over the years, these efforts have taken many forms of the research, in policy inputs, advocacy, and communication initiatives. In CMS Media Lab, we have been monitoring the prime time news and front page coverage of the newspapers and to see if the social and environment and other issues are highlighted in the media. And our finding shows that the coverage of the environment and climate change issues and the related issues are very poor in television as well as in the print media. As a follow-up actions, what we did, CMS then launched an International Environment and Wildlife Film Festival, CMS Vatavaran. Today, I am proud to say that this international forum is Asia's largest and among top 5 green festivals in the world, where we use the film forums and to engage with diverse audience like students, youth, policymakers, and the media. Yes, the advocacy unit of CMS is running major media engagement programs like with the UNICEF, with the WHO, GIZ, and with the Swiss Development Corporation, SDC. I'm glad to share with you that we had a long engagement with the SDC of 3 years program of media sensitizations program on climate change. And with the WHO, we had disseminated the information on the universal health coverage with the media persons, and fellowships have been provided to the media persons. This is the now coming to the CMS BEEP Media Engagement Program 2019-20. Media engagement program was developed and initiated by the Indo-Swiss Building Energy Efficiency Project BEEP. The program was launched among the huge gathering on 9th September 2019 in New Delhi by the economic advisors, Mr. Raj Ji. During the this program was launched during the BE International Conference on Building Energy Efficiency Program, ANGAN. The objective of this program was to create the awareness among the working journalists about the conservations of the energy and building sector. Under the program, many advocacy and training programs, workshops were conducted, fellowships were provided to the media person, and as a result of the program, many stories have been published in national and regional media. 200 journalists were trained in the face-to-face and online workshops, and 50 stories were published in the mainstream media. The first training program was held in Jaipur. This was a state-level workshops. This is some of the glimpses of the workshops where many state-level mainstream journalists have gathered and participated and have been oriented. Apart from this experience of implementing the energy efficiency building codes in the state was also discussed during the workshop through the very well-defined, well-explained presentations by the eminent experts of the building sectors. Other than that, participants also visited the Aranya Bhavan. The Aranya Bhavan, which is considered to be the first project selected for the BEEP integrated design chart. The second workshop, it was held in Gujarat, in Ahmedabad CEPT University, which is considered to be the environment-friendly building. And in this workshop, journalists learned that one of the department of the university, which is Center for the Advanced Research in Building Science and Energy, is contributing to develop robust database on building and energy scenario and tools for the compliance with the building energy codes. Other than that, participants also visited the Indian Institute of Public Health in Gandhinagar to understand how different features of the building make it energy efficient. Of course, the third workshop was planned for the Visakhapatnam, but due to the lockdown, we have to go for the online workshops only. But nevertheless, the participations was very participation and the participations was very well, and we have achieved our objective, whatever, though it was a offline only. This is the second component of the media engagement program. Here we have selected 12 fellows to provide the fellowships to 12 journalists of the media. Yes. The objective of the fellowship was to facilitate deeper understanding among the journalists so they can enhance the public awareness on the subject of the energy efficiency. These are the output of the fellowship program, where a total number of 40 stories were covered in over 13 different media outlets, which includes Hindustan Times, Times of India, Outlook magazines, India Today, Down to Earth, The Pioneer, News 18, Dainik Jagran, Rajasthan Patrika, Chitralekha magazine, and so on. After these fellowship programs, we also had a national media consultations where we have invited all the state level participants who have participated in the state level media workshops, and then they have shared their experience in the workshops, and fellows also shared their experience that how they covered the different story and the kind of the challenges they faced. Now, on the second phase, we have started this year, we focus is to train the media students with the aim to build the capacity so that they understand the links of the environment to climate change. Objective of the program is again to create the general awareness among the media students so that tomorrow when they will go to their respective careers, they'll able to write, have a knowledge and proper information to write on the subject or communicate on these various subjects. Yes, we used many kind of a tools to, it was a 1 week long training programs, and we used different kind of a tools. In-depth information was provided. Special tools were designed. Before developing the tools, we had done a conducted a need assessment survey among the different universities. And after that, on the basis of the findings, we developed with the help of the BEEP, we developed the tools, and that was tools were implemented. Many this resource material, discussion, quiz and exercise and mentoring throughout the training programs, the main tools which have been used to train the young minds. Best assignment award was also given. 25,000 rupees cash award was given to the 5 best media students who had done the best assignments. 2 best report on print media and digital, 2 best videos on broadcast media, 2 best advertisements for print, audio and video, and 2 best audio reports on commercial radio and community radio. Thank you. And this is one thing more I wanted to add, that this success of the program has encouraged us to go on to develop a kind of a modules, especially model modules for the universities, for the environment department and mass communication department. And we are now designing that kind of a curriculums, which could be the part of the main syllabus in the environment and mass communication university departments. Thank you. In the morning, we had many illuminating and insightful presentations. And we know that there is a lots of information and knowledge available on the issue of the building energy efficiency. But the problem is, and the issue is, how we can use such valuable knowledge and information to create the awareness among the general masses, and especially, I should say, to the end users. This session will focus basically on how we will try to bridge the knowledge gaps between different stakeholders for efficiently dissemination of the information on the subject like environment and energy conservation. To discuss these issues, I have very eminent panelists. Varnika has already introduced the panelists. So now I'll start to initiate the discussion. I think because media plays a very vital role in disseminating the information, Archana. So I would like to initiate the discussions with you. I would like to know from you that what kind of the challenge you think media persons face while writing the reports on the subjects like environment, energy, climate change, and I should say a very niche subject like building energy efficiency. What kind of a challenge do you face? Since you are representing the media, I think you will be reflecting everyone's, perspective.
First, I would like to thank CMS for inviting me for this important and very urgent forum, in the sense that now energy efficiency building should become, our way of life. Okay, now is it okay? Okay. So actually, first I would also like to tell that how I became, aware about energy efficiency building, because though I am in media, but I was also not much aware about that, what important role energy and these green buildings can play, and energy efficiency is very important area in our life. And then I was like, invited by CMS to do fellowship, selected by CMS to do fellowship on energy efficiency buildings. And during the course of doing my fellowship, I found various aspects of, this sector. And then I realized how important it is, and for our health, for, for our comfort as well. And given that we are having lots of climate change problems, issues, discussions, and but in climate change, we are just talking about politics, politics about the climate change and finance part, but rarely we talk about energy efficiency buildings. Now, second is like Anu asked me that what are the major challenges we are facing as journalists. One thing is, although journalists are, interested to do such kind of stories, but we have certain problems in the sense, like suppose if I am doing some story, I get like recently I got a report on this solar photovoltaic cells, that how they can help. But it was so technical that I couldn't get it. That then I dropped the idea, that leave it. Though it was very interesting on the face of it, but because I was myself not knowing how to write about it, so, and there was nobody to tell me also that what should I do, how can I write, how can I make it reader friendly, because first it should be reporter friendly. Such research are, if I am not able to understand myself, how I will be able to explain to my, readers. So that is the major problem. Technical things are there which are we are not able to comprehend or understand, decipher. So that is one. Other is it's not so easy to get space for green energy, such type of issues, because there are so many other which I don't find they are very important, but they get public attention as well as the media attention, and in the channel also you see that, all those things are being discussed. So that is also a challenge for us to cover energy efficiency, such type of topics. So for that, I would like that, if you people have some regular flow of information, like DST is doing, Department of Science and Technology, they that is also very difficult subject, because science is almost, it's a very technical, and you have to make it a reader friendly. So they are regularly providing us 2 or 3 stories daily. And there they have their own team where they write on the issue that, okay, this discovery has been done, or this thing invention, this has been done by their scientist. So and they give the email address or phone number of that particular with the scientist we can do. So if I am interested, if I have my space, like today I don't have, like it's Sunday, and I have sufficient space, and I want to write on green energy building, because space is very important. And if I get some stories, if I get in a little bit reader friendly, so I can make it more interesting, and it can be reached out to I can take it to my readers.
Archana, Mr. Dimansh might have answer of your questions. I'll ask the next question to Mr. Dimansh. Mr. Dimansh, as you know, the building energy efficiency is a very technical subject, but it has a practical implications. The challenge for media is to convey the message in very appropriate, and convey the message and have a very appropriate information on this by balancing the two sides. SDC runs many technical and media sensitizations program. What has been SDC's key learning from such other programs, which you would like to share?
Right. Thank you very much for the question. I'm not sure I will give you many responses, maybe many answers. Maybe I will raise more questions. Sorry about that. No, I mean, yes, we've had quite a few sessions. It's actually at the core of our intervention, not only BEEP, but also in terms of air quality, air pollution. We have a project on clean air also. And working with the media, trying to raise awareness is absolutely central to our intervention, because unless people are aware, there's no request for change. So it's absolutely fundamental. Now what happens is that we deal with energy efficiency, we deal with a subject that can be very abstract. That's one thing. I had recently the experience of a Swiss journalist who wanted to do a topic on energy efficiency, well, on the environment. And when I tried to sell energy efficiency, she said, no, this is not sexy. I cannot sell that to my. Okay, I mean, we are the wrong person to talk about it because we are so passionate about it that, that's the only thing that interests us. So maybe we're not very represented here. So how do we change that? Or it's too technical. And I think that's another issue, is that if it's too technical, people also cannot relate. They can say, okay, what can I do in everyday life? I'm not building a house, or maybe I'll build one in my life. But in everyday life, what can I do? How does it relate to my experience, to my life, and so on? And I think we have to translate what energy efficiency means into, first, why is it important? Why is it so fundamental? As Mr. Kumar mentioned, we are at a crossroad. What is happening, COP26 and so on, this is not at the political level only. It relates to all life, everyday's life. So how do we relate to that, what we can do about it? And the second thing, and things in metrics that people can understand. If I tell them about kilowatts and kilojoule and so on, they may, okay. If you talk about cost, like this bulb is 100 rupees, this one is 200 rupees. But after 3 or 4 months, you're going to save money because it will save more. Same with this AC. This is what you can do in your house by putting an external shading system. That's how much you will save. Then I think people can start to relate and say, okay, that's something I can do. That's something that will be good for me also. I'm going to save. And I think we need this kind of messages. I think that's very important. Now, what makes me very enthusiastic also is, a few years ago, you had to go to specialized newspapers and so on. You have a small section in the newspapers about the environment. Now it's everywhere. This last month, I think there was more coverage on air pollution in newspapers than in COVID. It was everywhere. I think people are starting to be very conscious about it, demanding change, and so on. And the environment is there. It's very much, and more there. So I think we have to show the positive sides of it. What does it change? It's not only cost, but not only about cost and so on, but what are the gains that we get into air pollution, in terms of quality, air quality, quality of life, saving and so on. This is very important. How does that relate to bigger debates, bigger issues? We talk about climate change, but if we want to solve a problem at the world, the global level, it starts with our country and it starts with our house. First, we have to solve it at the house level. Yeah. So, and basically be Gandhian, be the change you want to see, and how can you make this change happen? So I think this would be my my core messages. Sorry if I deviated a little bit from your question, if I took a bit long, but others can comment.
I think Vasanti will throw some light on that. Vasanti, you are heading a organization which is considered to be a media watchdog organization, and you have lots of experience of being a media monitor and evaluators. Do you think, what is your idea? Do you feel that there is a sufficient coverage of these subjects in the media? And what are the possible ways and the strategies to overcome these problems?
Thanks, Anu. And I think there are many lessons learned from our own experience, but also worldwide, about how media can play a very positive role. But when we say media, unfortunately or fortunately, even in this room, we'll only talk about journalists. But media is much broader, and now we all know that the ecosystem of the information landscape that we today belong to is really, really wide. And I just want to throw one little figure, which has changed during COVID, of course, but less than 10% of our, all of us, in fact, all the viewership in India, watch news. What are they watching then? They're watching many other things other than just information. And while I've spent all my life studying media and especially journalism and how it has impacted not only policy and practice, and how important it is to get agendas in the media to be pushed so that people know about it.
today I'm convinced that we need to normalize this discourse that we are having and go beyond just news. It has to be in entertainment. OTT, for example, is such a big platform today. If we can, I'm just looking, I was just thinking when Lal sir was presenting, can we not make a beautiful series on energy efficiency buildings in India and put it on OTT? Because anybody who's interested in making a house on this will certainly be watching Netflix or anything on that. Oh, there's an energy efficiency idea there. Oh, let me go see what are the examples. These are the mediums that will normalize the discourse that we are having here. It has to go beyond news. Certainly has to go beyond news today. And I know what Akshay has mentioned about the technicality of it. It is complex. The science is complex. It will be complex. And I'm very happy that SDC and DEEP projects and BE also are now put forward so much information in the landscape that anybody is interested can go and access it. But really, people who don't have time, especially journalists and people who are working on it, creative people who are working on it, will need another organization or experts to kind of demystify and explain it to them in simpler terms. So that's why, again, Dr. Lal asked Juhi, right? Varnika, to actually ask, will you be available if I want to know more information on this? Because that is important. Among all the things that Varnika explained, I'm also a member of the Advertising Standards Council of India. Again, in advertising, there's a whole creative industry who has absolutely no idea. And one of the biggest advertisers today is the infrastructure industry. How can we, involve? I know Sameerji, you and BE and SDC are also doing a lot of policy initiatives on the technical front, but also looking at the creative information space, looking at advertisers, for example. What kind of guidelines can we create for advertisers to ensure that minimum standards are mentioned when they're advertising for buildings, for example? Or for example, if somebody is doing a soap, it's a simple soap television serial. But even in that, when they're making a house, put a chick on the window, usse bijli bachegi. It's a simple thing which is normalizing a conversation that we're having. It's not promoting, it's not advertising. It's a simple normalizing what we do. And not making it expensive, it's not making it unique, it's not making it special, but to make sure that it's part of a behavior that is natural to us. Actually, you very rightly said, Ashokji, we have huge traditions in India. Unfortunately, we've lost all of them because we don't talk about it. We only look at what the West is doing. That's why we have these glass buildings everywhere in India also. So I think there is a lot we need to do in terms of normalizing behavior and practices that we all expect in this room to be practiced day in and day out. And I think, yes, of course, with the information knowledge that now BEEP and other programs, and especially SDC programs that they have created, working with the media and otherwise also will go a long way to build on now to ensure that these practices and policies and perceptions are strengthened, and ensure that energy efficiency is a must. If I'm building a house or I'm living in one, I need to look at these aspects irrespective of whether somebody's telling me or not. So it's a norm. And that's where I think media and all of us here play a very important role in trying to ensure that we do.
Yes, Vasanti, there is lots of knowledge on the subject. There is no doubt on that. But the issue is covering the subject like energy is use of lots of scientific jargon and technical jargons. Dr. Ashok, I would like to know from you, this is a bigger problem for those who are writing in an Indian language. According to you, what step should be taken by even Dr. Dimash also can answer this question. What step you and agencies and the national bodies like BE have initiated to tackle this kind of problems? Yes, at language level, lots of jargon, scientific jargon, technical jargon, which media usually feels it's a challenge for them to reflect it in a simple and the media language, which is easily understandable for the readers as well as the listeners or the viewers.
I think the question is very
can say a very good question, but the answer, I also think that from the Bureau's perspective, for instance, several, we are trying to, in a sense, we are bringing out publications, we are bringing out documents, as you know, this particular publication that's going to be launched, that will also have certainly the technical jargons. But we recognize, again, I will go with Dr. Jonathan's point that we would be here to raise more of a problem than we have solved much of it. Given that we also recognize that, the technical organizations like Bureau, basically we have our own set of languages to cater to a certain set of people to whom, and certainly there is a gap to reach to the last mile. That is definitely there. So within that, what we are currently doing is several capacity building exercises. For instance, there is an institutionalized training program for the retailers of the equipments that they sell, particularly to promote the energy efficiency or to educate the people at the retailer level. So that, and many of the outreach activities, we have radio programs, Bachat Ke Sitare, that there we try to kind of explain every part of the program in a very simple language, of course, within the limitations that Bureau and its domain of knowledge that we have. So we certainly recognize that issue, and even we recognize, we feel that, for example, we talk to within our departments. Say, for example, Bureau communicates to a different organization. They have their own sets of understanding, and we have our own sets of metrics. As Dr. Jonathan was saying, kilowatts and kilojoules, and other people will be talking about, masses and kgs and so on. So certainly those are challenges. But what I feel is that as we move forward, we are in the right track, and particularly this kind of media's involvement, and particularly prominent media involvement in the, spread of the message of energy efficiency or the energy as such. And the times, as we see that there is a space also that which has not been in the past, but we have now started to get those spaces. So I think we will further move, and as I was kind of hoping that this kind of interaction or the capacity building fellowships and so on are not the last, but this is the beginning, so that we can finally reach to the logical, place where we want to be. So that's where I think I would stop. Not much to offer.
So Dr. Dimanche, you would like to point out that what kind of a mechanism need to develop to sensitize the media in sustained manner? Because usually it's alleged that their medias are not sensitized in a sustained manner, only they are being asked or send the informations when there is some event or some major program. Otherwise, they are not getting a updated kind of informations or the datas or about new research about some new projects. So these are usually, it is alleged. So what is your point of view on that, that we should have some kind of a regular, some kind of a mechanism, institutional mechanism, where media can be sensitized on a regular manner?
Thank you very much. I think we got a lot of answers on this, and these questions are linked. This is linked also to the question of jargon and so on. I mean, I come from an academic background, and we are trained to write very complicated articles that nobody understands. Work in development, and you use another layer of very complicated jargon that nobody understands. And it's great to use the jargon because it looks, very serious and so on. But in the end, trying to communicate this into simple language that everybody understands, this is what is needed. This is the real challenge. And good communicators are rare. I know one very good one here is Mr. Ashok Lal, Dr. Ashok Lal, who can listen to ours and can communicate complicated things into simple language and inspire you. But I think this is, most of us, is not what we train in. And it requires a lot of engagement and so on. And we need to find these people. We need to find these champions. One way, I think, I also relate to what Mrs. Vasanti said before. The media is not only the journalists, it's not only the newspaper, the TV, and so on. How comes there's not a single movie? Climate change is everywhere, and it's going to shape our life for the next decades, hundreds of years. And there's not a single Bollywood movie on climate change that talk about climate change. How comes? Now, those who have bridged this gap here are actually the Bureau of Energy Efficiency, who hired Amitabh Bachchan to sensitize people about energy efficiency. And I think that's a great step. But how do we go further? So that's a call to all of you. If any of you know Amir Khan, please tell him that I would like him to do a movie about climate change. Oh, thank you. No, but I think all language can be translated, into all jargon can be translated into simple concept that everybody can understand. And the most simple story is about nature. You don't have any single species in nature that survives if it's not energy efficient, if it's not resource efficient. That's very simple to get, and that's a lesson for us as well. If we can't be energy efficient and resource efficient, I don't think there's any future. So let's translate things to simple things that we can all relate to, and nature is one of them.
Usually media is also, blamed, that it's alleged that media don't represent and reflect the stories or reports on a technical subjects as it should be. They are not reflecting the stories on these technical subject. Many of time it's trivialized based on very, generalized statement and not on evidences based. I would like to know first from Archana. Archana, in your view, what is the solutions to have a very authentic and quality report on such issues?
Again, we are coming back to same thing, like for authentic information and reporting.
Why so much generalized, and not evidence-based report? What should be done to overcome this problem so that we can have authentic and quality?
Archana, can I come in? I'll talk on your behalf a little bit.
Only one thing I would like to add, like I'm talking about my fellowship again. Like it was in when we were offered, there was no COVID, and then by the time we started, we had this COVID thing. So we had to do all the reporting just based on information, and we couldn't visit the places which would have given more, that feelings and everything. So that also meaning that helps.
I confuse flow of the information from the government sides or from the experts or from the scientists and the media people. So necessary that media should understand the perceptions of the scientists, and scientists and experts should understand the the language and the perceptions of the media. So that's why this is the question.
Yeah, actually, I wanted to add is that things have changed. So let's look at it from a very positive view. When we started at the Media Lab about almost 15-20 years ago, there was less than 0.0% of what was covered on environment. Today, if you see, there are specialized programs on climate change. You do get it. It's not that media is not covering. It's as you rightly pointed out, it would be general. It isn't talking about the
evidence based,
or it's not relating it to what can I do as a consumer to address that issue, for example, actionability, or in terms of policy. So, but it has come a long way. Let's give it credit where it deserves. And as the speakers also mentioned, that people are asking for it. People are aware about it. Look at pollution, for example, in Delhi. Now everybody knows about it. That's another matter that nobody, even in spite of doing so many things, we don't see the difference. But at least now I'm conscious about it. I do know that if I'm raising a child in Delhi, I'm reducing the child's lifespan. Making a conscious decision. It is unfortunate, but that's true, right? But we do know about it, and the media is talking about it. It's not that it's not talking about it. So the question that you asked, and one of the biggest lessons that I think the SDC program that we did for the Himalayas also is that there's a huge hunger among language journalists and local journalists to actually be able to write on technical issues. So we do need the technicalities, we do need the science. And these papers that you write are very, very important, because in the scientific community, they increase the credibility and understanding of the knowledge base that is built there. Having said that, how do you demystify that and relate it to, for example, a person living in Shimla? How does the climate change or the COP discussion relate to the temperature difference that Shimla, as a person staying in Shimla, face in, for example, apple crop? So as simple as that and as direct as that. So these kind of questions were asked, for example, in our workshops also. So
Yes.
we do need to bridge the gap between science,
That's right.
experts sitting here,
Yeah.
and media, to be able to have this discourse further. And the more discourses you will have, obviously you will get more crisper, relevant media coverage
And
that we
was-
deserve. And again, as I mentioned, like, we have to go beyond the mainstream media and look at how do we look at other medias, even the local cable wala, for example. How do we involve them? How
And
do we
Vasanti, do
involve-
you think that education or academic institutions can play any role in disseminating the information on environment?
They are
or
already
related
playing, I
issues?
think they are already playing a very important role. All education institutes, that job is to create awareness, to talk about issues. And now environment, climate change, energy efficiency, the prime minister is talking, the politics, all the important ministers are talking, we are talking. But we, like I said, it needs to come down to a daily discourse where I can understand and demystify it. And educational institutes have to talk about it because it's an important issue. As he's rightly said, next 100 years, we will be talking about this issue, and we will need more experts to be obviously talking about it in a creative manner, whether it's in films, whether it's in songs, whether it's in drama, whether it's in advertisements, about how the climate change or the energy efficiency is affecting me. And what can I do about it? Just like we had songs on Nadiyon ko, how important Nadi is, or Mother Earth is. We have songs on it, right? And for next generation, for children, we will have to create more on energy efficiency. So we will have to look at other ways and means, to creative means of communication. And of course, media will be always be very important. And a journalist like Archana will need to spend. Again, I want to end with just saying that in this ecosystem, especially in journalism field, we are looking at people who are looking for niche ideas and niche areas to cover. And journalists like Archana, who are covering these areas, will need help, like the example she gave of DST. So SDC programs and BEEP programs will certainly add to it, and more programs are such required, so that local journalists at different states are also helped and are given this technical input so that they can cover more. That cannot be bypassed. We need to continue doing that.
I think with
Yeah,
this,
I
yeah,
also
yeah,
feel-
yeah.
I
of course.
also feel that obviously newspaper or print is not only the media, that where you can reach out to people to understand the importance of, having, it's just like energy efficient building. Like we have so many mediums to reach out to people and talk about energy efficiency. But unless we have this sustained thing, like, okay, today we are having a program with media, and then it will be next year. So you need to have regularly feeding media. And again, I'm saying it's not print media, but it's through social media, Twitter, Nukkad Natak. There are so many ways, but you have to get into the mind of people that these are also areas where these are important in your life, like energy efficiency. So if you will not reach out to people, they will not understand.
Yeah,
If you
that is
see
sure.
big advertisements also, MNCs and big, these food industry and that. So what they do is regularly feeding your mind. Okay, eat this, eat this, eat this. So it becomes we become addicted to the thing, even if it is not good. But if it is good and you make it addicted, so that is, we will be serving the cause also.
I think with this, we can conclude the sessions, and three very important suggestions have emerged with this in this dialogue. One is to simplify the resource material on technical issues like building energy efficiency. Second is there is need of an institutional mechanism to sensitize the media and through the media to the general masses. Third one is continuous communications channels are required with the government department, with the other stakeholders who are involved in creating the awareness. So these are the three suggestions. I think it's emerged from our everyone's responses. I'm thankful to all the panelists. And now over to Varnika. We will be having a lunch break. Okay. Okay. Yeah, of course we can take the question. Can we, Varnika? Is there time? We can take some questions. Yes, if there is any questions, yeah. Please, kindly.
Hello, I'm Kanagraj. I work in the area of building energy efficiency for some time. Just two things which I thought like could be an add-on to what media is doing is to make it more user-centric or user-led market. One is like looking at the platform through which a common man finds the property like 99acre or Magic Bricks. If there is something there which can be looked upon by the user in terms of selecting his or her property, that would be very connected to the person. And the second thing is the intermediaries like JLL or CBRE who help various corporates find office spaces or residential spaces. If they can be educated, that would help. I have seen that sometimes they are counterproductive. Let's say in case of JLL and CBRE, we have seen certain clauses where they say that air conditioning should be not more than, let's say, 4,000 square feet, 400 square feet per ton. Okay, which is not a case for a low or a high performance building, right? We can go to 600 or 700 square feet per ton. So those kind of clauses are counterproductive in terms of finding energy efficient buildings for the client. So something related to that can be addressed by the Bureau or the SDC would be useful too.
Yeah, it is a observations. So you need to have an answer for that? No. Okay.
May I start?
Yeah, surely.
One idea came in my mind and which I shared with Mr. Lal also, and he was excited for this. So I thought to share it here also, and it is very pertinent also. Like nowadays in NCR, if you ask anybody, what is AQI? Everybody knows that what is AQI and what is the number required. Similarly, we have to create a buzz point number in this area also, and which Mr. La suggested that this could be ENS. Less than 15 is not acceptable. More than 15, less than 15 is acceptable, and more than 15 is not, means it is not energy efficient and all that. So similarly, initially this could be a promotional number for builders, and later on through legislation we can go ahead. But this is the one number which the buyer will see, and he has some impression that yes, the flats and building is energy efficient. So this is the very shortcut and focused dent to the in the mind of buyers. Thank you.
Thank you for the suggestion. Yeah. Anybody else? Yeah.
Hi, I'm Kanchan Sidhe from VK Environmental. Furthering to what Sir just shared, I believe Econivas Samhita has like a passport kind of a thing, which is very attractive. And there are many stakeholders in this room, from consultants, government agencies, media. I'd just like to share that as BE already has a network of ENS and ECBC cells throughout India, with where these cells work with each SDAs. And these cells also work in the local language. So for example, in the past, when we served as a cell, we created posters and informative material, which was essentially transformed from a more technical language to the easy to understand language in, say, local language. So I feel there is an immediate opportunity to tap that and have some interactions where the cells are already operating today. So they've they're already appointed both on commercial as well as residential projects under ECBC 2017 and ENS. And I see a great opportunity there. If that forum can at the local level share it with the local media, it would really be fruitful is what I'd like to share.
Yeah, I think it's a very good solution. Yeah,
Thank you.
thank you.
A very good afternoon.
I
I
think this
also-
will be the last question.
So I also
Sorry,
have
sorry.
a small suggestion, not a question, but something like the star labeling program for appliances, and something on the similar lines was initiated for residential buildings also. I think sensitizing the occupants of how the energy they are consuming and what is the impact of that energy consumption. So something in the electricity bills could also be incorporated, where a consumer is shown that how you are compared with the benchmark or with or similar homes in the city, how much you are consuming against them and what is your contribution towards energy efficiency. I think those kinds of indicators or rewards are something that people can actually see, because that is not evident to the consumer unless they see that their bills are rising. That's the only pain point when the consumer sees. But if you are also able to sensitize them that how much they are using as compared to others, I think that could also be a very good initiative to start off with.
Yeah, thank you.
Yeah, can I just add to, I think the very wonderful suggestions. I think this is perhaps the first session that, more of a dialogue than a monologue that is goes from here. So certainly all the suggestions has its value. So in some of the areas, I think B has already in action, for example, star rating of building is already in place. We are doing in that direction. And some of the discoms are doing exactly the way that you are suggesting, the peer comparison, and you would see BSES bill. If you see, you would see certainly where are you compared with the other, similar kind of a household. So wonderful suggestion. I think that so as I was mentioning that, we need every intervention, any small intervention that can result in a saving, that can result in improving the comfort, anything, outside, inside, up, down, rooftop, wherever it is possible. So ideas have to flow from, all sectors. And I think everyone has to go do our part. Ultimately, the challenge for us is a common challenge. We can fight COVID by putting mask, containment zone, but the challenge of climate you cannot contain, you cannot mask. So that is a bigger challenge. Until we recognize that enormity of that challenge, we need to really work hard, or even harder than what we are doing. So with the kind of suggestions and involvement that I see here, we are very hopeful that, we would certainly keep alive the 1.5 degree sustained situation alive. Thank you.
Yeah, and have a group photo.
Yes.
With plants.
Plants.
Thank you so much. We will break for lunch and reassemble at 2 p.m. We will have the inaugural session of the launch of the public knowledge product. Yeah. So please make sure that you are back by 2 o'clock. Bye.
Hello, hello. Hello. जी मैं वो चेक चेक कर रहा था कोई है उधर क्योंकि जूम में हम बहुत कम करते हैं ना
हेलो आलोक सर, आपकी आवाज आ रही है हमें?
हेलो हेलो
कनेक्ट करो एक बार। वर्णिका एक बार कनेक्ट करो वहां पे।
हेलो
हाँ, हम आवाज आ रही है, तुम जरा वहां से कुछ बोलो ना, हमें यहाँ आवाज आ रही है।
अभी किसी का आया था
हाँ, अब आपको आवाज आ रही है?
हाँ ओके ओके हमारी आवाज आ रही है ना आपके
यस यस यस
ओके ठीक है थैंक यू इसको मैं ऑफ कर देता हूँ फिर
सर बैठ गए हैं, बाकी लोग नहीं दिख रहे हैं सर को यहाँ पे, जो वहाँ का व्यू जो है, व्यू जो है वो नहीं दिख रहा है सबको। सर नहीं नहीं, आप लोग करो क्योंकि मैं यहाँ कर नहीं पाऊंगा, तो आप लोग ही वेलकम रिमार्क करो, सभी को बोला। Samir ji go and Jonathan want to speak something? Jonathan? ठीक ठीक, तो वहाँ से आप वेलकम कर दीजिए, सर बैठ गए हैं, आप दिखा दीजिए, स्टार्ट कर दीजिए, 2 तो बज गए हैं, ठीक है, और सर को वेलकम करके देन सर लॉन्च करेंगे एंड देन सर तो आप कर दो, ठीक है, ठीक 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 ठीक, जी जी जी, आप थोड़ा क्लोजिंग कर दीजिएगा सर। सर स्क्रीन पे कुछ नहीं,
फ्लो क्या है इवेंट का?
सर फ्लो हमने ये वाला स्पेशल सेशन रखा है।
उन्होंने इसमें क्या क्या है इसका
तो
मिनट
इसमें
मिनट का हाउ डू यू इसका flow?
वेलकम अभी एसडीसी से देंगे आनंद शुक्ला जी, देन आप लॉन्च करेंगे। आप
आनंद शुक्ला जी कौन है?
आनंद शुक्ला जी जैसे मैं यहाँ पे हूँ डायरेक्टर, वैसे ही वो वहाँ पे हैं स्विस डेवलपमेंट के।
All of you to please take your seats. People who are having lunch, we request you to please take your seats. We'll start the launch session shortly.
मुझसे पहले क्लियर करो ना।
हाँ क्लियर करो,
इसको खोल सकते हैं।
ये किस तरह का वर्क कर रहे हैं, उनका ये रिकॉर्डेड सेशन है।
इंजीनियर तो काफी कम लग रहे हैं।
इंजीनियर्स भी हैं, यही है ना सर?
Welcome back, everyone. So we will be starting with the launch of our knowledge products today. We have been graced by the Secretary Power, Mr. Alok Kumar's presence. He's joined us through video conferencing. I would also request Dr. Anand Shukla, Senior Thematic Advisor, SDC, Dr. Jonathan Demonge, Head of Swiss Cooperation, SDC, and Mr. R.K. Rai, Secretary, Bureau of Energy Efficiency, to please join us on the stage. I would now request Dr. Anand Shukla to deliver the welcome address.
Thank you, Varnika. Good afternoon to all of you. I'm Anand Shukla from the Swiss Agency for Development and Cooperation. After the technical sessions in the session in the morning, I think it was a scintillating discussions that we had, and that was followed by the media session. I think that gives a clear opening that there are issues and concerns on the topic of building energy efficiency. But at the same time, we have also discussed about the number of solutions that we have in tackling those challenges here. So in line with this, we have with us Shri Alok Kumar, Secretary, Ministry of Power, Shri Rai, Secretary, Bureau of Energy Efficiency, Dr. Jonathan Demonge, Head of Cooperation from SDC. And the occasion is to launch the 4 publications that have been prepared by the Bureau of Energy Efficiency with support of the B project. And these 4 publications are understanding heat transfer in buildings through numerical examples. The second is building envelope solution sets for EcoNivas Samhita 2018. Third is the Vayu Prava and open foam software tool on computational fluid dynamics. And the fourth is manual on external movable shading system. So with this, I kindly request Shri Alok Kumar, Secretary, Ministry of Power, to please launch these publications. Thank you.
The book on heat transfer. The manual on external movable shading systems. And the building envelope solution sets for EcoNivas Samhita 2018. And the Vayu Prava tool. Thank you so much. I will now request Mr. Alok Kumar, Secretary, Ministry of Power, to give his keynote address.
Thank you so much, Mr. Jonathan, Mr. Rai, Mr. Anand Shukla, and all the dear delegates and participants. I'm very, very happy to speak to the delegates of National Workshop on Energy Efficiency in the Indian residential sector. It is all the more a great moment because we are celebrating several events, and this workshop is part of that chain as a part of our Azadi Ka Amrit Mahotsav, which we briefly call AKAM, A-K-A-M. Azadi Ka Amrit Mahotsav is a national celebration and which is inspiring us to showcase our achievements on the completion of 75 years of our independence, and also to take and to accept new goals which we want to pursue till say 100th year of our independence in 2047. So this is a great occasion, and I am told very renowned architects and other important other very say distinguished delegates have been attending this workshop since morning. Let me begin by saying that India is a growing economy, and our energy needs are huge. And as we develop further, our energy requirements will also grow. Just to mention that currently our capacity to generate electricity from all the sources is around 392 gigawatt. And it is estimated that by the end of this decade, that is by year 2030, this capacity will go to more than 800. To be precise, we estimate it will be 817 gigawatt by the end of 2030. Currently, our generation of electricity is in the range of 1,500 billion units a year, and it is estimated that our electricity requirements will go up to more than 26 or 2,700 billion units in year 2030. So we need this energy to grow, to develop our economy, to raise the standards of living of our citizens. But at the same time, as a responsible country, India has been taking and very successfully steps to see that our energy growth is responsible, and we meet whatever we have committed to the global community as a part of our Paris Agreement nationally determined contributions. And India has showcased very good success to the global community in COP26. India has been successful in achieving a number of the NDCs before time. Our goal for reducing the emission intensity of our economy with reference to 2005 year level was around 33% by year 2030. We have already now touching around 28%. And our Honorable Prime Minister has announced in the recently held COP26 that this goal is now being raised to 45% by year 2030. Similarly, apart from the enhanced target of 500 gigawatt of non-fossil fuel-based electricity installed capacity by 2030, India is now have taken a new commitment to reduce 1 billion tons of carbon dioxide in this decade. So these new aspirational goals which India has announced, we have also announced a carbon net zero by year 2070, because we are still to peak our emissions in the times to come. So these ambitious goals have raised aspirations, and whole world is looking at us, that we need to take steps urgently, that whatever we have announced, we achieve it in timely. And I'm very sure that India is taking all the necessary steps to see that our commitments are met in time. The energy efficiency is one of the main vehicle for achieving India's nationally determined contributions. I am told around 50% of the awarded carbon emissions, they are a result of our energy efficiency measures. Other important initiative is the enhancement of the renewable energy contribution in our energy supply. So out of this energy conservation, India has done exceedingly well in terms of industrial energy efficiency by the PAT program, the Perform, Act and Trade, Perform, Achieve, Trade program. We have done a very good work in say promoting energy efficient appliances, We have also initiated a number of initiatives for energy efficiency in MSME sector, and our flagship program of Ujala, that is distribution of LED bulbs. They have all facilitated and enabled us to achieve the target so far. We have taken so far steps to promote energy efficiency through law and regulation in the commercial buildings. But now a change is now happening, and India also proposes to amend its Energy Conservation Act to bring large-sized residential building complexes. Individual dwellings we are not envisaging to bring under the legal obligation, but the large-sized residential complexes, they are now being given an obligation to adopt energy efficiency techniques in construction, in their interiors and all. And ECBC, that is Energy Conservation Building Code, is the main instrument for enforcing that. So why residential buildings? I am told the buildings as such, as a vertical, they consume around 31% of the total electricity consumed in the country. That is why buildings are the main source of electricity consumption in the country. And if we have to achieve the goals which we have announced at COP26, we have to see that all the new building stock, especially the large size building complexes, they are energy efficient, because once you make a building logged into for 30, 40, 50 years. So it is very, very essential that the energy efficient techniques and materials is used right at the design stage and construction stage. It is all the more important because India is poised to urbanize very rapidly in the next 1 or 2 decades. India has not seen still the large scale urbanization, but its economic growth will be critically dependent on large scale urbanization of our country. More the urbanization, more the new buildings, and we'll see huge residential complexes coming up in all the old cities and new cities. And the 75% of the energy demand in buildings comes from residential buildings. So this is a very important segment, and I'm very happy that Bureau of Energy Efficiency has taken several steps, not just to only mandate the energy efficiency measures in building sector, but also to see that we have adequate capacity, training, skills, the technical material for all the stakeholders, for the developers, for architects, for the contractors, for the agencies who build buildings. And I am very happy, I am very pleased that BE has today launched these 4 knowledge products. I must congratulate Bureau of Energy Efficiency that whatever area they take into for energy conservation, they see to it that there are sufficient technical material available in an easy to use manner for all the stakeholders, for industries, for electric vehicles, for buildings, for MSMEs. And I must appreciate these 4 knowledge products. I'm very sure that these products will go a long way in facilitating implementation of energy efficiency measures in building sector. And we have very open approach. Whatever suggestions would come out of this workshop or otherwise also, both the Bureau and the Ministry of Power will be very glad to look at those suggestions and to see that our implementation framework is further facilitated. And this is again a very important event for us, very important workshop. And I look forward to the outcome of this workshop. If there are any further suggestions for improving our implementation framework. Once again, thank you very much. My best wishes to the workshop. Thank you very much. Thank you.
Thank you very much, sir, for this motivating word, putting things in perspective, releasing the 4 publications here. it really motivates all of us that, the work that we have been doing has a national importance. Thank you very much, sir, once again.
Thank you. We now have a film on the knowledge products that have been developed. So we'll just watch the short film.
The Government of India and partners are celebrating India's 75th year of independence with Azadi Ka Amrit Mahotsav. On this occasion, special knowledge The Government of India and partners are celebrating India's 75th year of independence with Azadi Ka Amrit Mahotsav. On this occasion, special knowledge products on building energy efficiency developed by the Ministry of Power and the Bureau of Energy Efficiency with support from the Indo-Swiss Building Energy Efficiency Project are being launched. The knowledge products created under the program aim to mainstream building energy efficiency best practices. Book on understanding heat transfer in buildings through numerical examples. This is a book for undergraduate engineering students, which comprises of 20 numerical problems with solutions to explain heat transfer in buildings. Building envelope solution sets for Eco Nivas Samhita 2018. This document is a very reckoner for architects and construction agencies to help meet Eco Nivas Samhita 2018 requirements. Vayu Pravaha, an open form software tool on computational fluid dynamics, CFD. Vayu Pravaha helps building designers map the natural ventilation potential of a building. The Vayu Pravaha is a first of its kind tool to be developed, which shall be available freely. Manual on External Movable Shading Systems, MSIS. This manual details out the MSIS products available in India. It lists different kinds of products with the thermal performance, application, operation and maintenance details to help architects, building designers and developers. Guidebook for Awareness Generation on Energy Efficient and Thermally Comfortable Buildings and the Guidebook to train the trainers on Energy Efficient and Thermally Comfortable Buildings. The manual has been developed with the objective of making available a reference document to media persons and journalists to help them report responsibly on the issue of energy efficiency in buildings. Additionally, a manual for training of trainers has also been developed. We invite you to use these knowledge products to carry forward our combined objective of mainstreaming energy efficient building design in all parts of the country. Come join the building revolution to build a cleaner and greener India.
I will now request Dr. Sameer Mehta to present mementos to Secretary Bureau of Energy Efficiency and Dr. Anand Shukla. We will now move to our third technical session on heat exchange and ventilation in residential buildings. The first presentation is by Mr. Pierre Zheboydov, which is on the Vayu Prava, the CFD tool. We have a recorded presentation from Mr. Zheboydov since he couldn't join us physically here.
Just because there are some questions, so all the publications which have been released, these would be available when you go out. So after this session, so at the desk we have the copies, so you can collect them there, and they will also be uploaded. Yes, please.
Mr. Zheboydov is a partner at Affinat Sal, a firm based in Lausanne, Switzerland. He's also the head of the Swiss Project Management and Technical Unit of Indo-Swiss BEAT. He holds a master's degree in mechanical engineering and has over 35 years of experience in the field and specializes in building simulation, CFD, and integrated design of buildings. So he has also joined us remotely, but the recording is, the presentation is pre-recorded.
Zheboydov. I'm part of the Building Energy Efficiency Project team, an Indo-Swiss. Zheboydov. I'm part of the Building Energy Efficiency Project team, an Indo-Swiss project, and I will present you the main feature of the new software which has been developed called Vayu Prava, which is a free software for the simulation of wind-driven air movement around and inside buildings. Just a few words about the technicalities of this software. So it has been developed with the support of the University of Applied Science of Sion in Switzerland, with Dr. Jean Dequet as the main scientific advisor. And then I have been the coordinator and the leader of this development. The software is based on OpenFOAM, this OpenFOAM simulation engine, which is the only validated, publicly available software, but very difficult to use. And this environment is running on Windows 10 PCs with about 16 GB RAM. This is what we advise. And there is a user manual which will come with the software on how to use it as well. So a few words about the concept. If we look at, we can ask ourselves the question about how is it that the wind direction influenced the air movement during the hot summer? Then the building layout, of course, of a project with the density we have nowadays in country like India in the urban context is very high. And then, of course, the facade design can influence also the way the air can enter or pass along the facades. So one of the main questions is that often the design are based on intuition, and very often arrows are drawn, but they may not follow actually the air movement. And outside very simple cases, hand calculation are not very sufficient and often even impossible. So, and the commercial computational fluid dynamics software, CFDs, they are very helpful, but they are very expensive and out of reach for many consulting companies, including in Europe. And that is why this software, Vayu Prava, has been developed to be a free software which can allow a much larger audience to perform wind-driven air movement analysis. And the main goal also is that the CFD should be very fast also in its calculation. So a few of the main feature, you can go from a district level for the calculation. You see here an example of the map of a district in a country in Switzerland, in a city in Switzerland. And you can see here the results of the calculation with the velocity. And it can come to a single large project or to single buildings. It's possible also to simulate inside the building, which has been added for the version of or that we present now. As mentioned, it was developed by BIP and the University of Applied Science. The methodology has been published in the Journal of Physics after presentation in the CISBAT, the International Conference in Lausanne in Switzerland. Few things about the scientific development of Vayu Prava. The picture presents the comparison between the wind tunnel measurement and commercial software as well as Vayu Prava. So you can see here that when we look at the velocity of the air before reaching the building, you can see that the line, the diamond, is actually in function of the height of the flow. You can see that the wind tunnel are the diamonds on the line. Then you can see that the flow vent, which is a commercial software, and then open foam with the line, they are matching quite good. So this is the first kind of comparison which was done also. Then we did some other comparison between commercial software and Vayu Prava, and you can see here the comparison matching the colors exactly between the two scales of airflow around 9 buildings with a kind of diagonal flow. And you can see here the flow around calculated with flow vent and the calculation with open foam and the Vayu Prava. You can see that the matching is also quite good. Then we have also added the facility to calculate inside the building. I'll show you later some more details about the actual simulation. So these are things which have been got in a wind tunnel with actual measurements, and we can compare the velocity profile. So you can see the points here along the air is entering on the left and then going through the building and going out. And then the A, B, C, D, E, F, G are this cross section where the wind has been measured in the wind tunnel. And you can see the blue square points are actually what has been measured in the wind tunnel. And you can see in violet the curve which is calculated with Vayu Prava. So you see that the matching is quite good. Now, if we look at how do we think we can use this software. So the first thing is to get drawing from an architect or a client developer. Then we can introduce it in the software in the DXF format, and then we can prepare the simulation by setting the wind, etc. condition. Then we can get a simulation. Normally the simulation are done within few minutes if the case is not too complicated. Then after we can also modify the building layout. I'll show you after. And then we can compare different alternatives. During the use of the software, each time we have results, we can also generate PDF files. So we can compare the results between two alternate design. This is just to show an example here. And then we can also later, if we want, or from the beginning, work on designing internal flows in a building. That means by working on opening on facade and setting up one floor, for instance, on a building of 10-story, you could select one floor to calculate internal flows. And then you get comparative results within buildings also with the velocity and the pressure. So if we look at how you are working with the software, you have to prepare the DXF file. You need a little bit to clean them before entering, but normally this is very fast, or you can redraw quickly the the polyline of the buildings. And then you can import various shapes of building actually with internal courtyard or funny shapes of all kinds. And it can go up to a district kind of situation where you can also simulate such large. Then after you can set the height from the DXF plans, you can set the height of buildings. And then you can prepare the simulation. There you need to set up the environmental condition and like the wind direction, its velocity, and the reference height that you get from the data you have. We think here essentially at night velocity and direction during the hot summer. That's where you are trying to do the night cooling by cross ventilation, and then you can launch the simulation. Then during the simulation, a pop-up windows appear displaying the status. So the first bar, when it's blue, this is the meshing. Then the second bar, when the simulation after the meshing has been completed, the second bar show the remaining time. Typically, simple case are calculated like the one I have shown before within few minutes with a PC with 4 physical cores of type i7. And at the end, the blue bar showing that the simulation is over with this view sign. And then by clicking on done, you are going to the results of the simulation. So here you can have different results, show parameters or variable that you show. Here we show, for instance, a position of, if we have 25-meter height buildings, we have the airflow velocity between the buildings from a far distance wind at 3 meters per second and at the height of 18 meters around the buildings. You can see here, we can also add labels to visualize locally better the velocity. And here you have the scale, which is helping. And then, of course, there are quite few visualization possible with the software. One is visualize the velocity around the building at different planes, whether it is on the vertical or horizontal axis. You can also have the pressure around the buildings. You can also have pressure on building facades, which is also very useful because when you want to get an idea of how the airflow can go through a building, you get here first think that if you get the pressure on both sides of a building where you think it could be opened through or a kind of cross ventilation, it gives you a good idea if you get absolutely no pressure difference between one side and the other side. Another thing, you can also see the streamlines, which is more indicative. Another presentation, which is the threshold, the visualization, is that you can see a domain, for instance, where the velocity is between in a domain of values, or you can also have clipping planes. That means you can cut the building and visualize the airflow inside the building. Even if it's a 10-story building, you can go, let's say, at the 5th story and have a look into the floor that you have selected to be simulated in detail. So after you have one result, you can always make a new alternative design. So you can either move, for instance, the building number 7 in this, we move it by translation. The number 6, we move it also by translation, and the building 9 can be just rotated. So just to show you can translate or rotate, and you can select different buildings. Then once you have a modified case, you can run the two, you can calculate by simulation the different, and then you can compare the results by generating PDF files. That means which can be comparable approximately at the same height, and you get the velocity between the buildings for the two different layout, and then you can see how it can be changing a lot depending on the way you do it. So the importance of the building layout is really of major importance. Of course, it is a multi-parametric criteria to make orientation of building. It's not only the wind, but the wind, at least you can get a clear idea on what is the influence of your building layout on the airflow. Then we can also, as I mentioned, have an internal flow. So here I show you quickly, for instance, that if you have the base of the building, which we say is a rectangular shape, then of type A, we call it, that is one layer. So you make a first layer up to the floor you want to simulate in detail inside. Then you can add the closed part of the facade, which has a specific kind of profile. This is the B level, and then you add the C level, which is the part of the facade which has openings. And you can design things to test different architectural features to get either by opening shutters or windows or outside to get the air, getting the air entering when the air is going along the facade. And so this is one example. Here you have the wind direction, which is facing the longest facade of 3 buildings, which are one after the other. So you can see here that we have very good air change when we are on the first building because it is located windward, but the next buildings hardly have any wind cross ventilation potential. So it's very important to try to see whether you can change it. So here we have taken an extreme example. We have really rotated completely the 2 buildings. And you can see here that by doing that, we can really having a facade which has a little bit a specific design to get the air to enter into one flat and then cross in the corridor, for instance, or depending on the design, and then go out on the other side. You can see that by changing from this situation to this situation, of course, this is an extreme schematic case, but we show here, you can visualize that you have a much better velocity in the 3 buildings at night. So it can help in thinking about the way you are designing building layouts. So in a summary, I would say that the first thing is Vayu Prava is a freely downloadable, real computational fluid dynamic tools. It gives results for most of the typical case in few minutes, which means you could allow optimizing in real time during multidisciplinary working meeting between the developer, the architect, the engineers, the green consultant, etc. You can directly compare different layouts of buildings and even strategies inside the building, that means the facade design. So it seems it's a good addition to EcoNivas Samhita as it is giving more information about the potential for night cooling, especially. And there will be a download link which will be given at the end of the training program to tomorrow on Saturday, 11th December, to the people who registered. Thank you for your attention.
So thank you, Mr. Joboidov. He has joined us virtually. So if you have any questions, we will take it at the end of the session. I will now request Professor Udairaj to come and give his presentation. Dr. Udairaj is an assistant professor with the Department of Mechanical Engineering at IIT Bhilai. He specializes in computational fluid dynamics, thermal comfort, building energy efficiency, thermal energy storage and management. He has been involved with BEEP as a faculty member for the BEEP student camp and is the primary author of the book on understanding heat transfer through numerical examples.
This is working right. Okay, so good afternoon, everybody. So as we saw in the previous discussion or previous session, the book launch. So one of the knowledge product which was released today was the building heat transfer understanding through numerical examples. So basically, before going into the content of this book, let me just briefly give you the background of this. So as we know that if you want to basically realize energy efficient building, so the design engineers are expected to work along with the architects. So we had a BEEP camp in 2018. So where like there was a brainstorming session on how to train the engineers and what are the possibilities as far as building science is concerned in the engineering education. So it was realized, or it was felt during that BEEP camp, that the basic understanding related to building physics is kind of missing as far as engineering education is concerned. So based on that, and then there are other complicated issues also, like as far as the engineering is concerned. So I belong to mechanical engineering. So even now also we basically talk more about the conventional problems. Like say, for example, I will talk about, means people prefer boiler as one of the important problem, right, compared to let's say building, right? So basically we are still in that conventional domain as far as conventional courses are concerned. So considering that, and there are limitations in terms of the courses which we can offer to engineering graduates. So considering that, it was decided, or it was felt that let's try some experimentation where we can actually integrate the building physics or building related problems in the existing courses. So one such course which is very relevant is the heat transfer. So based on this discussion and the background, so we started the IIT Bhilai and BEEP actually collaborated together, came together, and we started developing few numerical problems which can be easily integrated with the heat transfer course or the engineering curriculum. So and the mandate of those problems were that these problems should be India centric, right? So and whatever data which we are going to use in the development of these problems should be realistic. So so we took a lot of data from the actual measurements, experimental measurements, which is conducted as a part of BEEP projects. So there are many projects which BEEP has contributed, like Aranya Bhavan, which was discussed earlier. Then you have the Smart Ghar project in Rajkot. So like that, there are other projects. So the data for these problems is taken from those real measurements, or some data is taken from the building simulations. Okay, so now I will quickly go through these problems and what these problems offer. So the idea of these behind the development of these problems was to introduce engineers to the some of the key concepts related to building and introduce them to the building physics, or basically give them some idea about the passive design, building energy efficiency, and so on. So with this, what we have done here is that there are certain topics which we discuss as a part of heat transfer course. So let's say when we talk about heat transfer, so we have different modes of heat transfer: conduction, convection, and radiation. And throughout the course, we talk about various key concepts like thermal resistance, composite walls, and so on. So, and as an architect and as a practicing engineers, so all of us know what do we mean by U value, right? So, and there also we calculate U value as a part of our curriculum. But those U values we usually try to link them with the problems like furnace, boilers, and so on. So in this case, what we have done here is that we have used that concept of thermal resistance and composite wall, and we actually tried to develop some problem which will give them a feel of some of the key concepts related to building. Like, let's say, for example, there are problems which talk about the effect and importance of building wall insulations. Then what is the impact of insulation on roof, right? And then what kind of wall we should use, and what is the impact of different type of wall on the cooling load of building. Then which roof construction is effective in terms of simple numerical calculation. So based on simple numerical calculations, so they will be able to kind of come up with the optimum roof construction. And what are the impact of different properties of the roof material? Yeah. So, and then there are problems related to coupled convection problems, which talk about the effect of air tightness, effect of wind speed, and on the heat transfer and the cooling performance. And also when we talk about data collection or the real measurements in buildings, so there was a study which was discussed earlier, where it was said that using the external movable shading can reduce temperature by 3 degree or 3.5 degree, right? So measurement of temperature is one of the concern, right? So how to measure those temperature, what kind of sensor we should use, what is the role of shielding materials in temperature measurement. So all these things are discussed in this particular problem. Then there are other problems which are related to radiation heat transfer. So while explaining the key concepts related to radiation heat transfer, we can tease them the effect of building orientation. What do we mean by SHGC? How to calculate the SHGC? So basically we talk about SHGC in real window selection, right? So with these problems, what we have done here is that with the simple key concept which they learn while learning the heat transfer course. So basically with simple fundamentals, they can actually calculate SHGC value for different windows. So one such example is given here. And then what is the role of mean radiant temperature on the thermal comfort? Then there are problems related to the conventional air conditioning system and radiant cooling system. It kind of compares which cooling system is better with the help of simple calculations. And then the top floor problem, which Lalji was talking about. So one example is given there. So what is the effect of means if, let's say, someone is staying at different floor, so how the thermal comfort is affected. So there is a problem related to that. And then there are very comprehensive problems which are there in the book, which basically talks about the single pane glass window versus double pane glass window. And also there are problems which talk about double pane glass window versus the external movable shading. And then it also talks about means there are numerical problems which where the window to wall ratio and its effects are discussed on the cooling load, natural ventilation, and daylighting. Right. So this external movable shading problem I already talked about. And then there are certain problems where kind of comprehensive human heat balance is discussed and how thermal comfort is evaluated. So that is also discussed. So these are the 20 problems. So I briefly tried to talk about those. So now I would like to give you just a quick, I'll not go into technicality of this. So I'll just give you two numerical problems which are there in the book. So in this particular problem, So basically, we are talking about the concept of thermal resistance and its application in building energy efficiency or building heat transfer. So here what we have done is that we have selected 3 roofs. One is normal roof construction, second one is roof with reflective tiles, and third one is a painted roof. Right. So for this, again, the data which we have taken for this in the development of this particular problem is basically related to Smart Ghar project, which was supported by BEEP and which is located at Rajkot. So, so in this case, so all this data is taken from the real experimentation. So, and based on this and the simple calculation related to the thermal resistance and U value, so this heat transfer in all the 3 cases is compared. And the good part of this problem is that at the end of each problem, we have given a lot of remarks which basically explain a lot of key concepts related to building physics, right? So basically what we do here is that we take a problem and then we try to solve it. And then at the end, we try to, with the help of the solved problem, we try to relate it and we try to discuss some of the key building physics concept. So in this case, we can see here that, so out of the 3 roof configuration which are considered, so the heat flux is least in case of painted roof, right? And you can see the inner roof surface temperature and outer roof surface temperature in all the 3 cases. So once we get these results based on the simple calculation, so in the remarks section, we basically talk about which one is important, what are the advantages and disadvantages of different roof construction. Right, so now the second exercise is related to the radiation heat exchange. So again, let's not go into this. So we know that the component, if they are located at different, means let's say far apart from each other, they exchange radiation. So and the amount of radiation heat exchange can be calculated, right? And it depends on their orientation also. So based on that, and there are, so whenever we teach heat transfer and radiation heat exchange, so basically we talk about how to calculate those radiation exchange between, let's say, one wall and the other wall. So such kind of calculation is again very relevant as far as building heat transfer is concerned. So in this case, what we have done, we have taken a room of a certain size, which is located at Raipur. So in this case, there are 2 systems which are installed, either one of them. So in the first case, you have conventional air conditioning system, and in the second case, you have radiant cooling system. So in the given problem, so in case of conventional air conditioning system, the indoor air temperature is maintained at 27 degrees Celsius. And in case of radiant cooling system, the indoor air temperature is maintained at 30 degrees Celsius. And then based on the simple calculations, the amount of heat which is lost or which is exchanged between the human being and the building environment is calculated in both the cases, right? So it's basically radiation plus convection heat transfer. So now based on this, you can see here that in both the cases, like air conditioned room as well as room with radiant cooling system, the amount of heat lost is almost same. Like in one case it is 65.27, in other case it's 66.78, right? So it's almost same. So it basically means that whatever heat is getting generated because of metabolism, so is going out from the human body, right? And so basically thermal comfort depends on the heat balance, right? How much we are generating and how much is going out from the body. So basically it means that in both these cases, the person is going to experience same level of thermal comfort. So, but one thing which we should remember here is that in case of conventional HVAC system, the air temperature was maintained at 27, And in case of radiant cooling system, the air temperature was maintained at 30 degrees Celsius. So basically there is a 3 degree Celsius temperature difference, or 3 degrees Celsius temperature was higher in case of radiant cooling system. So which indicates that, and we know that from our past experience and from the literature, that if we somehow increase indoor air temperature by 1 degree, so we can save around 6 to 10% energy consumption. So it basically means that in case of radiant cooling system, we can maintain higher temperature, let's say around 3 degrees Celsius. So basically it means that the radiant cooling system is more efficient. So I just pasted it here, the entire discussion. So just to highlight that a lot of discussion is also there at the end of each problem. So that's all from my side. Thank you. So I think we can take questions later, right?
Thank you, Dr. Udayaraj. Our next presentation is by Dr. Dibakar Dakshit from IIT Delhi on advancement and research on energy efficiency in residential buildings. Dr. Dakshit is currently an associate professor at the Center for Energy Studies, IIT Delhi. He has 19 years of experience in thermofluid sciences pertaining to design and optimization of energy systems. His interests lie in energy storage devices, battery thermal management systems, polygeneration, heat exchanger, green building concepts, etc. His PhD at the University of Western Australia involves studies of multi-phase mass transfer phenomena related to thermal diffusion of liquefied natural gas. So I welcome Dr. Dakshit. Load your presentation.
Yeah, so good afternoon, all of you. Today I will be discussing in brief regarding various research pertaining to building energy conservation to enhance the building energy efficiency, which we are doing at our thermal devices and testing laboratory, IIT Delhi. So some of the glimpses which I will be showing over here today. So I think from ECBC, we are quite clear that when we speak about energy efficient building envelope is one of the key factor which comprises of building facade, that is the building walls and the roofs. And again, we are going into more details of the building facade, then building material selection, which is the key factor for designing a building facade is to be given more consideration. And there are basically two types of factors which actually help us to understand how the heat gain in a particular control volume, if you are speaking about a room of a building, is taking place. So the external factors pertain to the solar convection radiation, which comes through, which gets diffused through the building roofs and walls. And again, of course, if you are having windows and then various leakages, which can also act as the infiltrating agent in that particular control volume, basically comes with the various heat gain, which is responsible for the external factors. Besides this, we have various internal factors also, like the appliances which we utilize in the inside that control volume in that room, and the occupants. And if we are having lighting, of course, we have lighting. So depending on that, we contribute towards the heat gain which is there inside the room of the building. So I think it is quite clear to us from Bureau of Energy Efficiency's finding that if we want to have a building with 30 to 50% of energy saving, so that is pretty much available if we can have an optimization on the building envelope, because you can see the various heat gain through various building envelope, through roof, through glazing, wall, and of course through infiltration, the amount of heat gain which we are having. So when we are speaking about optimizing the energy or to maintain the thermal comfort inside a control volume, if I am allowed to say building one of the rooms as the control volume, so then we want to some way or the other optimize this heat gain by doing some control, by providing some control mechanism over those building facade, I mean the building envelope. And if I'm speaking about the indoor environmental quality, then there are various factors. One is the thermal comfort, then lighting, air quality, and of course there are other factors like odor and noise. But here we will be more discussing about the thermal comfort, keeping in view how to optimize the energy consumption in that particular building. And that too I will be more highlighting on the various passive features which can be taken into consideration. So when it comes to passive features, one of the factors through which we can have an optimized building envelope is utilization of phase change material in the building envelopes. So to just exemplify or to make it equivalent to what we used to have in our heavy vernacular construction or the mud houses or various ancient buildings, say for example Humayun tomb or any other ancient buildings which we don't have that luxury today to have such huge thermal mass by providing a huge space. So there comes the requirement of phase change material, where with limited space we can have that same effect of vernacular buildings so as to maintain the temperature of the control volume to its optimum possible level. So that way we wanted to conceptualize it. And then there are various factors which we discuss about, like the growing rate of urbanization, people moving from villages to urban areas, massive construction coming up, which will actually lead to huge energy consumption in terms of the electricity consumption and in terms of various other energy which is required for the primary requirement of the people who are dwelling in those areas. So this PCM incorporated brick, or you can say the PCM incorporated brick wall, by maintaining the Indian standards, the codes which has been recommended by Indian standards, we are one of the areas which we have started exploring to see how they can actually help us to maintain the control volume at an optimum temperature level. So this is one of the researches which we have done. Next one is regarding a repository of phase change material, where on the basis of the melting point, we want to pick some commercially available phase change material and then map it according to the requirement of heat gain which is there in that particular climatic zone. We all know that India is having prominently 5 climatic zones. So according to those climatic zones, if we can map the various commercially available phase change materials to see how they can be utilized within the building facade, that will help us to get a holistic picture of all the phase change materials which are available, and then they can be utilized. This is one of the work which was assigned to us by Department of Science and Technology to find out a repository and then to map it with the local requirement and have a kind of, you can say, a repository of all those phase change materials. So it is quite exhaustive. I am just showing a bit of it on the basis of the various climatic conditions which we have in India. This is regarding the bricks, in which we have macro encapsulated some of the readily available phase change material which can be utilized for composite climatic condition of Delhi. Since we are housed in Delhi, so we did some experiment by utilizing this phase change material, by macro encapsulating those phase change material in the bricks without compromising with the structural stability, because we can't compromise on that. So we had a bit of optimization over there. So you can see that there are 3 cases where we have either macro encapsulated at one place, or we have dual PCMs which has been macro encapsulated in the brick, and then we are having other PCM being compared with the other 2 cases. So similarly, this type of macro encapsulated PCMs were actually installed in the building walls to see how much of temperature reduction we can have inside the room without compromising on the thermal comfort. So that was the main idea. Of course, this is another avenue which we have explored, like increasing the thermal conductivity of the phase change material. This is quite on the scientific side, so maybe I will not go into more details of it. Just to make you understand, this phase change material actually works as a thermal battery. So this phase change material, they can store heat, but they inhibit from diffusing the heat. But when we are speaking about a thermal battery, it should actually charge at the same time discharge, but they don't have that characteristic of discharging when and where it is required. That's why we want to find some means through which we can actually diffuse that heat also. So that is one of the limitations of this thermal battery which we wanted to explore. But again, means if I'm speaking about the cost and the holistic way of installing it, it is means it is not a very feasible way. Scientifically, we can see some light, but actually I will not say that. Still, it is not in that stage where we can find a solution with this phase change material. So these are some of the key conclusions which we have found. So as I was mentioning that it is done for Delhi, so you can see that the phase change temperature which ranges, melting temperature which ranges from 34 to 38 degrees centigrade for the 2 commercially available phase change material, we can have a reduction in the inside temperature by say from 5 to 7 degrees centigrade. So I'm not saying that we can totally eradicate the utilization of air conditioner, but suppose the outside temperature, say in summer, in the month of May, the solar air temperature can shoot up to say 45 degrees centigrade. But to get that temperature reduced from 45 degrees centigrade to our thermal comfort of 26 degrees centigrade, that is a huge gradient. But if some way or the other, we can reduce it to somewhere say 39, 40 degrees centigrade and then reduce it to 26 degrees centigrade, that delta enthalpy which we are giving directly will impact on the electricity consumption which we are having. So this is one of the key takeaway from this. Second is this utilization of this phase change material or any insulation inside the building or through the facade, the thickness as well as the location. So it is quite challenging. Like suppose you are doing it for Jaipur, you will have a different location for sandwiching that phase change material when you are doing it for say Kargil or Siachen Glacier. Ultimately, the aim is to have a comfort temperature inside. In Kargil, we are in the freezing zone, and in Jaipur, we are on the summer side, like the high temperature zone. So this thickness versus location conundrum is quite challenging, and no one has explored it, especially for Indian climatic condition. So we took it further. We designed an optimization through an objective function, where we have taken the thickness of this phase change material and the insulation as well as where it should be placed. So these were the two criteria which we have kept it in mind, and then tried to come up with some optimization utilizing genetic algorithm. Anyways, I don't want to go into details of it. So the outcome of this genetic algorithm powered optimization for the utilization of the phase change material along with the insulation to fix the location at a particular in a particular facade at a particular location, say for Delhi. We found that for Delhi, actually the phase change material calcium chloride hexahydrate, it is an hydrated salt with polystyrene as the insulation. If we are posing them inside the building facade, then it gave a most optimized situation where we can have the temperature to its minimum possible level. So next one was how to employ it. So we have taken Pradhan Mantri Awas Yojana's blueprint because it is the mass building construction which is happening in and around various urban areas. So we have taken one of the blueprint and then tried to employ this utilization of phase change material and insulation, keeping in view the climatic condition of Delhi to see what type of scenarios were being encountered. Of course, here we have also done an optimization utilizing the structural and the orientation optimization. Suppose means bylaws may not always allow to have the best orientation. So what is the next best orientation which we can orient our building to according to the situation which we have? So keeping in that mind, in our mind, with the SHGC factor of 0.25, which is being recommended by Energy Conservation Building Code, of course, we have not taken into consideration the relative humidity because in Delhi, we know that say from the month of August till September, we have that type of August, September, October maximum, we have that type of scenario. Other than that, it is only the temperature part which is quite critical. Anyways, we can include it, but here we have not done. And we tried to find which is the most optimized orientation for a building, keeping in view the type of phase change material and the insulation which we can introduce for that particular Pradhan Mantri Awas Yojana's blueprint. So these are the key insights of the employment of phase change material and insulation in Pradhan Mantri Awas Yojana's blueprint. So we can see that we can optimize the envelope and with a heat gain of around 54 kilowatt per hour of per day, and we can have a non-optimized concrete which will have such a high 82 kilowatt hour per day. And if we can have this type of heat gain reduction in this Pradhan Mantri Awas Yojana's one unit, so we can see that more or less around 9 kilowatt hour per day of electricity saving for an air condition with an approximate coefficient of performance of 3 can be achieved. So this is a huge saving if we can some way or the other employ this type of measure in mass urbanization, which is happening through this Pradhan Mantri Awas Yojana. Secondly, we have introduced a machine learning and deep learning based approach to predict the thermal performance of the phase change material based integrated roof. Here we have not taken the wall, we have taken only the roof. So it is basically a AI based algorithm which helps us to quickly predict, you can say an analysis based design where we are not going into the deep construction or doing some experiments. By taking some input on the basis of the data which are available. So we have developed an AI based algorithm to find the thermal performance of this phase change material embedded building roof. So there is one measurement key response parameter, MKR index. Anyways, it is a bit on the again physics side. I don't want to get into details of it. Just keep it in mind. This is the factor on the basis of which we can adjudge whether a particular phase change material can be appropriately utilized in a building roof so that the temperature can be kept at its minimum possible level. Here we have not done any experiment. By utilizing AI, we have come up with this mechanism. So we have utilized, of course, machine learning and deep learning. I don't want to get into the details of what all machine learning algorithms we have used. Of course, in deep learning, we have used AI. And then means as it requires train data and the data input, so we have splitted it appropriately. It is more to see which one is giving the better result. So we have seen that this deep learning model, it exhibited the higher accuracy over other machine learning models for a PCM integrated building roof to estimate this MKR index. So that gave us an overview of how this MKR index can be used to adjudge the performance of a particular building roof when it comes to the facade. This is the last one. I will not take much time from you. So we know, like now we are going through the trend of pandemic. So means you can see then how the virus is changing its strain. So starting from say somewhere early 2020 till now, we have reached somewhere where now Omicron is becoming more prevalent. So now we require the recommended air change per hour, which WHO has suggested. And at the same time, we want to optimize the amount of energy which is being utilized in a particular building. Because if you are having sufficient air change per hour, it is directly coming on the electricity consumption. So how to optimize that? So for that, we have developed a model, a CFD model, by taking into consideration the recommended 12 air change per hour of WHO in a control volume in a room, by keeping in mind all the COVID protocols which should be there, like 2 meters distance between the two person who are in that particular control volume and so on. So the main objective was to maintain safe, healthy and comfortable indoor environment or indoor atmosphere with minimum HVAC power consumption through envelope retrofitting. Here also we have done some retrofitting in the facade by taking into consideration the phase change material, insulation in the building facade, and again how all the COVID protocols should be kept in mind. So those two things were taken, and we have done this was highly appreciated. And then LCVR Public Health Emergency Collection, this paper got published and it is being highlighted over there, so you can download it and you can see that what type of features has been included in this particular CFD study. So this is more details of how two people are to be maintaining their COVID protocol inside a control volume when they are lying, and all other details. And this is the test matrix where we have taken 2 inlet air temperature with the recommended 12 air change per hour of WHO, and then we try to minimize it because we want to reduce the air conditioning load, so as to see which one is the better one to follow the protocol, and at the same time to minimize the energy consumption. And of course, we have done the retrofitting with phase change material and thermal insulation. So these are the results in terms of the 24 hours indoor heat gain and the cooling energy which is being supplied for all the 24 cases, the permutation and combination of all the 24 cases which we have shown in the previous slide. So the results are quite promising, where we say that if we can have a thermal insulation as an effective envelope retrofit, then of course the recommended 12 air change per hour, which is on the higher side, can be somewhat minimized to 8 air change per hour, which will be actually reducing the HVAC load without compromising on the health or the people who are inside that room, without compromising on their health. So this is something which I wanted to highlight. So yeah, means it is saving life. This means model is attempted to save life, ecologically saving earth, and at the same time holistically it is saving energy. So these are some of the ongoing work which we are doing on, again, thermal load optimization of a building, where we have done the optimization utilizing building massing and orientation, building envelope, building walls, and again building windows. So basically this is the ongoing work which we are doing at this point of time. And the second one is, again, this is actually quite an interesting one, where an existing building can be retrofitted. We have taken the workshop block of IIT Delhi's Department of Energy Science and Engineering, where we have retrofitted the workshop block building facade, the roofs, as well as the building walls, to find out which is the most optimum configuration which can be utilized to have this ratio, this EPI index to its minimum possible level. So we have tried various combinations of various passive features of shading, cool roof, and again phase change material. And of course, since it is an analysis based design, so the same blueprint or the same model of building can be stationed at different latitudes. So we have tried to study through all the different cities, prominent cities of composite climatic condition of India. So we have taken, other than Delhi, another 3 cities to find out which is giving the most optimum configuration for minimizing the building load. So the combined effect of cool roof with phase change material or insulation, that showed a very promising combination, where in comparison to that of any other combinations, where we can have the minimum energy consumption by keeping in mind the thermal comfort of the people inside the room. So these are the overall conclusions. I think I have gone through it, so I don't want to get into more details of it. Of course, I have given a bit of idea about the cost related to this utilization of the phase change material in the building facade. So overall, you can see that it is a win-win situation where we can actually have thermally comfort environment, and at the same time, we will be not having the consumption of electricity more. So these are some of the publications which came out through the group. Thank you for your attention.
Thank you, Dr. Rakshit. I will now request Dr. Udairaj and Dr. Methil to join us on the stage for the Q&A session.
Yeah. So I would like to thank all the 3 presenters, because I think we had 3 very good presentations and covering different aspects of building physics. And so we will have a question answer session. We have received some questions from the audience who are attending remotely, but I think let us go first. I can see 2 hands there. Professor, yeah. And Pierre has also joined remotely. Yes, he is there. Okay.
Yes, I'm there.
I'm Professor Chitralekha Kabre from SPA Delhi. I have been into building science. I have written books also. My question is to Dr. Rakshit, who has illustrated how PCMs can be integrated. And I think that is one of the potential application in our country. I would like to know how much percentage of energy saving did you find with respect to base case? Because you illustrated in the end a graph, and there was a base case and then different. So in terms of percentage, it is better to understand. Because I'll just add one thing, that I also did a study on Econivas Sahita. This year in the January, there was a national level competition, and what we did in the 5 climatic zones of India, we modeled a building with Econivas Sahita provisions, and we could find there are significant saving compared to a base case. So I now like to know what is the saving we are achieving with PCM.
Sure. Am I audible? Yes, I'm audible, right? Yeah. So thank you. This is a very relevant question. So we have to see the various conditions through which we are designing this like scenario where we are having phase change material in the building envelope and then the outside climatic condition. So it depends on that case, that criteria. Like if you are going from say somewhere in Delhi to somewhere in Chennai, so again the energy savings will be different. But what I have done, it is for Delhi's climatic condition. And as I have shown, like if we are speaking about Pradhan Mantri Awas Yojana and then trying to employ this phase change material like this calcium chloride hexahydrate and the insulation, the polystyrene. So if the electricity consumption was prior around 80 kilowatt hour, so it has been reduced to somewhere around 50 kilowatt hour. But again, it depends from case to case. If you are going to some other climatic zone, you may not get that one. And then when I was speaking about the bricks, there also I have shown that at least there will be a temperature difference of 5 degrees centigrade if you are utilizing phase change material between outside and inside. If not 9 degrees centigrade for some of the cases we have got. So now you can see that delta T. So then you can multiply it with the specific heat of air and then the mass. So that way you can calculate how much of enthalpy you will be means actually playing with when you are utilizing this phase change material. Does it make sense?
Yeah, thank you very much.
So first of all, thanks a lot to all the panelists. It was a very informative and a very knowledgeable session, and very unlikely that these kinds of sessions happen. So I'm very fortunate that I was able to attend this. I have a question for Mr. Jabudev. So first of all, really glad to know that there is some kind of a open source tool that has been developed for CFD. And it is very helpful for consultants because otherwise CFD is a very tricky and very specialized job. So I have a question. I mean, I'm just curious to understand that for CFD, boundary conditions and surface coefficients and meshing, that is a very important aspect. So how does this tool relate to these things? Is there a recommendation given to the user, or do they have their own choice to make these inputs into the model? The second question quickly I have is that you were talking about wind driven simulations. Mostly in residential buildings, we see that there's a lot of restriction on cross ventilation and we have to make ways for single side ventilation using buoyancy. So will this tool also help us to estimate those effects? Thank
you. Can you hear me?
Pierre, you will have to unmute yourself.
I'm on mute. I'm not muted. So
we are not getting the sound here.
Mute and then let me.
Can we unmute him from here? Who unmuted it?
Hello, I think I'm not.
Okay, so I think what we will do till Pierre comes back. Dr. Udairaj, you wanted to answer something?
So I think in this particular tool, there is no option to adjust the mesh right now. So this option is not given to the user. So yeah, so it will automatically do all those things. Obviously means for CFD, as you rightly pointed out, this meshing and boundary conditions are actually very important. So boundary condition, I don't think in this case it's a problem because it is given to user, like you can define the wind direction, wind speed and all. But yeah, this meshing will play a major role. And right now it's not given to the user because anyway, means you also know that it's a complicated matter, right? So for practicing architects and also it's actually difficult to basically define the proper mesh size and all. which type of mesh is to be taken. So from that point of view, I think it's fine. Like it's a kind of not perfect, but it's kind of optimized.
Yeah. So, but just to tell people that tomorrow there is a training program of almost 4 hours on this tool. So I hope, like, I think I have seen almost 350 or 400 registrations already. So peer will be there. So I think this particular question, if you are attending the training program, that will also be addressed there. As well as you can also write a mail if you are not able to get peer right now. Yeah, in the meantime, let us take another question. Yeah.
Hello. Good afternoon, everyone. I'm Shravani. I'm currently pursuing MSc PhD in Energy Science and Engineering from IIT Bombay. So I have a question to Dr. Rakshit. How do you comment on the cost effectiveness of the phase change materials? Like, do you think the general public would welcome these materials? How do they welcome, and how they do have questions about the cost effectiveness? They have things that they don't understand. So how can we take it to the general public and the normal masses?
See, I have shown some cost related slide also. There, what is the cost of an ICOSEN and OM35? Again, just by taking into consideration Delhi's climatic zone. So in that one, we should have a very detailed, I will say, techno-economic analysis to be done to find out where we are getting the return back. Having said that, there will be definitely some apprehension at the beginning, but when there is mass production and people start seeing that, of course, it is making a change in terms of the electricity consumption. When their bills will be going down, then definitely it will be convincing them to, and it is not a one-day thing. Like as we all say that Rome is not built in a day, so it will take time. But that eventual process should at least start by sensitizing people with that. It is something I have shown the cost also, like 600 rupees 600 per kg sort of thing for OM35. So of course it is involving a cost, but you have to do a proper techno-economic analysis to see when you are getting that money return. And once it comes to that point of inflection, then it is a win-win situation.
Okay, Dr. Rakshit, there is a question from one of the person who has joined remotely. Is in your slide number 18, is insulation better than PCM? Referring to slide number 18.
Can you hear me now?
No, here I have shown a combination of insulation as well as phase change material. So that I was telling now, like a thickness versus location conundrum. It is not only how much amount of PCM you have to deploy, it is also the location of the PCM through that building facade, whether you should employ it on the inner side or outer side or somewhere in between. So that optimization study, again for climatic condition of Delhi, has shown that a PCM with an insulation when being employed at a certain location in the building facade will be giving us the best optimization with the reduction of around, say, from 80 to 30 rupees kilowatt hour per day. So it is not single one, it is two, combination of both PCM as well as insulation.
Okay, just one more thing. Are these genetic algorithm powered optimization, is it available for everyone, like the algorithm?
Yes, it is available. You can go to any say MATLAB or Simulink, any one of those, but you have to tailor make it. But I just wanted to add in this one, this genetic algorithm which we utilized, there we have done some more fine tweaking so as to incorporate, because generally it was happening that they will be only speaking about the thickness or they will not speak about the location. someone will speak only about the location, they will not speak about the thickness. But to incorporate both of them, there was no talk before this. This we have not uploaded in the MATLAB that module, but in some of the genetic algorithm toolboxes are there, even in MATLAB, even in Python and everywhere. You can utilize them readily.
Just to add on this, so the generalized code for genetic algorithm, there used to be a lab, genetic algorithm lab at IIT Kanpur. So you can go there and you can download it from there also.
It's called Kangal, Kanpur Genetic Algorithm Lab, and it was developed by Professor Kollanmoy Deb, who is now in US.
I have a quick question for Dr. Udairaj. When you showed about the radiant cooling system and because the surface temperatures are there and then you are trying to estimate how much cooling it will do. Are there any numerical solutions for estimating that, or you are using some software for that?
So in order to get the temperatures, world
Yeah.
temperatures, so I think this is taken from the existing data which is available. What are the surface temperature of different walls and roofs for the existing buildings?
Is it using the solid geometry or you have some?
From the actual geometry, means actual data, experimental data.
Okay.
Okay, so I have one question for Dr. Udairaj. Like, since this you have developed this book, and you have also conducted 2 faculty programs, no? So what has been the response and what is the plan for further disseminating this book to educational institutes?
Okay, so I think in the last workshop which we conducted in the month of August, so the response was good. So there were 2 workshops, one in August and November. So, and as far as first workshop was concerned, so there was a panel discussion also where faculty or panelists from various IITs and other reputed institutions also came together. So, and there were many faculty members who are actually teaching heat transfer and other relevant subjects at different IITs, in different IITs and NITs and other reputed institutions. So the response was good. And I think it's a new concept, like there is something new, a new area is coming. And I mean, I think people liked it because the way we teach heat transfer right now, it's very conventional. So now, so people like the idea, like the faculty member who are teaching these kind of courses, so they like this idea, and we received a lot of suggestions from them. So probably we'll have more such workshop in future, and I think there are few things which we can do to take it further. So I don't think right now there is any good book which is available, which is basically talking about as far as building a heat transfer, right? So there are certain reports which are available from IIT Bombay, so which is available since very long, I think. But now there is no basic book which is basically talking about the fundamentals of building heat transfer and then take it forward. So probably such kind of books can be developed where which these I hope this kind of books will be helpful not only for engineers but also architects. So where we can talk about basic fundamentals of heat transfer and then about building physics also.
Okay, thank you, Dr. Udairaj. Also, I would like to also mention here that Dr. Dibakar Rakshit was one of the reviewers of this book, and along with Professor UN Gaitonde from IIT Bombay. So they were kind enough to review this document, and as Dr. Udairaj said, we have plans that once now it has been released, we will be sending it to almost 500 educational institutions in the country, as well as we will work out how we will take it forward from there. The other thing, is Pierre back? No?
Can you hear me now?
Okay. So, so then the other thing was that on the CFD tool, so tomorrow we have the first training program, but please feel free to write to us. We will be having a series of training programs. So tomorrow is the first one, which is a 4-hour program, but which we will be trying out that that whether this 4-hour is sufficient or not. So because a lot of effort has gone into developing the tool, so for next 1 year, our main effort would be that this tool gets used. We will be also establishing a help desk where, like, if suppose you encounter any problem, we are able to address that. And then also trying to see that while a lot of current development of the tool has happened on the Swiss side, in a longer term on the Indian side, where it can be sort of hosted, and further development of the tool can take place, as well as it is made available to larger number of practitioners. So I think that is sort of a beginning of a process, and we look forward to sort of further sort of taking this work during the next 1 year. So, Varnika.
So I think we've come to the end of the session. We'll just present mementos to our guests. Thank you so much. So we come to the end of today's session. And I'd like to thank all of you for coming all the way to attend this event, and all our online participants as well. We also extend our thanks to the Bureau of Energy Efficiency and Ministry of Power for their support to hold this event. Thank you so much. We have tea outside for everyone.
active camera.